Hello, welcome to another stream. How about that? How about that? Are we good? Are we pog? Sorting pog? Hello, everyone. Welcome to another stream. Hello Out9, Apparently Potatoes, Rus Sekfold, Cerimon, Mr. Botka, 0x7001, Yatanasov, Shigiman, Katison, Erhan Kornez 2000. Hello, everyone. Sasalala23, Aiguduk, welcome. Really glad to see you all today. Today is Saturday, the day of the Saturn, and today, according to the schedule, Lazy Grid, hello, I'm sorry, I missed you, like Rotten Chumsy, Pez Bug, and White Knife, hello. So, today, according to the Skidoodle, we are supposed to be doing game development, but since yesterday's stream got cancelled, right? Wait, oh, fuck. Oh shit. Hello, today is Friday, and that means today, according to the schedule, we're supposed to be doing one-off random title, random stream. Fuck. How do I fucking stream? Alright. So yeah, today we're supposed to be doing random one-off streams, so basically when I choose a random topic, but since yesterday's stream got cancelled, I moved the yesterday's stream to today, right? And today we're doing Advent of Code 2019, so on Thursdays, I plan to just go through the whole Advent of Code archive and solve all of them, and yeah. So right now we're doing 2019, and 2019 challenge is to solve all of the 2019 problems in Haskell. We're gonna do that in Haskell, no matter how much stateful code the problem will require, no matter how difficult it is, it has to be solved in Haskell. No exceptions, except the exceptions in Haskell itself. So you can find the source code of all of the problems we solved so far in here. There we go. So it's located in github.com/sodding/AOC 2019, and let's just jump into it, I suppose. Alright, so it's gonna be AOC 2019. By the way, if you're interested about my solutions in 2020, you can check out these links. So yeah, we have two repos for AOC 2020. For AOC 2020, we did another challenge, basically a different language for each day challenge. And we successfully used 25 different languages for 25 different problems. Isn't that amazing? Including even assembly. Look at that. Even assembly. We solved the most difficult problem in assembly. That was goddamn poke. Anyway, so let me actually fetch the other stuff for this thing. Alright, so let's do git merge origin master. Okay, so I think updated some of the things. Let me start the Chromium. So the thing I did, if I remember correctly, I added the links to the screencasts. So now, by clicking on one of these days, you will also get a link to the screencast with the proper timestamp, and you can see me solving this problem, the recording of me solving this problem live. So isn't that cool? Isn't that educational? Because this is an educational channel. You've come here to educate yourself. Go educate yourself. That's the motto of our channel. All right. So the next problem is the fourth one, right? So I'm gonna create this thing here. So the fourth day. What's cool about Haskell? Nothing! It's a language for nerds! There's nothing cool about it! We still haven't tried force, to be fair. To be fair, who needs fourth if you have BM? BM is also stack-based. I mean, why not? Oh, another interesting challenge for Advent of Code. I think by the time... Well, I mean, yeah. So essentially, when the BM matures enough, solve all of the problems, Advent of Code problems in BM assembly, like in Boson. I think that would be actually pretty cool. I think it would be actually pretty cool. A language for unemployed people, maybe. All of the Haskell developers I know, they all employed at very good companies, actually, very like huge companies at very high positions. The problem is they don't program in Haskell there. So I wouldn't say that Haskell is for unemployed people. But yeah, a lot of people who program in Haskell, they don't do that professionally. Are you a boy? Yes. Yes, yes. All right, let's continue. Let's continue. Let me see. So I'm gonna. I know, right? Crazy. You would never guess. I was lied to. Well, I mean, sure. There are different girls. So let me see. Let me see. So let's go to Advent of Code 2019. And let's go to the fourth one. Make snippet for main module. You know what? I think it's a pretty good idea. Okay, thank you by the way for reminding me constantly to make snippets, because yeah, I just never realized that I keep repeating the same thing over and over again. So yeah, yes, new snippet. Name is gonna be main, this one, and this is what we're gonna put here. And I guess that's it. I don't think anything else is required here. So choose or enter the table. Can you just save this? Okay. Save to main. Directory does not exist. Okay, create one. Cool. Does it automatically reload? I don't remember. Oh, nice. I really like how, yeah, fucking classic. So that means I have to go to my snippets in Haskell mode, right? And I have to enable one of the flags, if I remember correctly. It's something like fundamental mode. Maybe it's not a fundamental mode, maybe it's some GNU make. Yeah, this one. Actually, I wanted to put it here. So, and another thing is what? I want to do yes, reload all. Okay, and let's just reload all of that, and there we go. That works. That works beautifully. Isn't that amazing? I think it's goddamn amazing. Rocks, yeah. Sodium sometimes sounds like an Australian. Yes, because I am. I'm actually Australian. Okay, so secure a container. All right. You arrive at a Venus fuel depot, only to discover it's protected by a password. The elves have written the password on a sticky note, but someone threw it out. However, they do remember a few key facts about the password. It is a 6-digit number. The value is within the range given in your puzzle input. 2 adjacent digits are the same, like 2, 2 in 1, 2, 2, 3, 4, 5. Okay, 2 of them is the same thing, okay. Going from left to right, the digits never decrease, they only ever increase or stay the same. Okay. Like 1, 1, 1. Okay, that makes sense. That makes sense. Other than the range rules, the following are true. 1, 1 meets this criteria. Double 1, 1 never decreases. Does not meet the criteria. Okay. Does not meet the criteria. No double. How many different passwords within the range given in your puzzle input meet this criteria? Okay. Isn't that difficult to fucking brute force this motherflipper? Let me see. So what's the difference between them? Oh my god, come on GHCI, come on. It's so slow. It's just my potato. Okay. Zozin, why are you still on part 2? Part 1, I mean. So what's the difference? Really? Like, come on. Seriously? It's just this 500,000. It's fucking 500,000. And, oh my god. Alright, let's quickly do that, I suppose. So let's put it somewhere here. So how many digits possible within the range in your puzzle input meet the criteria? Okay, so we need some sort of a function. 5000k, yes, it's so dumb, holy fuck. Like, even if it was million, it would still be affordable. Even 10 million is still affordable to brute force. Like, it's just so dumb. Okay. How are we gonna call a function that meets the criteria? Is valid, right? So it's gonna accept an integer and returns a boolean brute force undefined. Okay. Oh my god. Valid. Okay, I'm gonna keep it like that then. Then I'm gonna just take this thing. All right. Is filter is valid. Filter is valid. Then count all of these motherflippers and then just print this entire stuff. There we go. It's as simple as that. As simple as that. Let me enter the force day. Is it reference? Is yes, it is. It is. GHCI main.hs. And yeah, okay, I better rename it because I'm gonna keep mistyping it. I'm gonna keep mistyping it. Is valid. Okay, so if I try to run this entire thing, it fails at undefined, so everything is okay. Everything is okay. So what kind of criteria do we need to check here? We know that it already contains 6 numbers, right? It already contains 6 numbers. We can convert it to a string and then just check all of that. I don't know. Something like x, show x, and then we can check is increasing, right? Is increasing. Right. I can actually call something like this. Is increasing and contains double. We can actually like check these 2 criteria separately. I think it's gonna be okay. So then s is just basically show x and is increasing. All right. How can we quickly check if something is increasing? Well, yes, I'm that fucking lazy. Anyway, so how can we check if it contains any doubles? Well, I have even more epic solution for that. Well, not descend. Yeah, not descending. So yeah, we can use set, something like nub. It's actually nub is kind of bad idea because it's square, right? It removes all of the duplicates, and it's a square. But since we have only 6 elements, it doesn't really matter in my opinion. So essentially, contains double s is nub s length is essentially less than the length of s itself. There we go. So we are essentially removing the duplicates, and that should work. Anabothu, hello Anabothu, welcome to the streams. Okay, so what I'm thinking is that maybe we don't even need to pass any of this shit, because I think, I mean, we're within a single scope. Does it really fucking matter? Does it really fucking matter? We can just do something like this. And since the language is lazy anyway, it's gonna work out. Trust me, I'm a professional Haskell developer. Alright, so if I try to do that, it's not gonna work because we need to import data list to have an access to all of these amazing functions like sort and nub. If I try to run this entire thing, it's fucking slow, but we know that there's 1099 elements that are in fact valid. And if I try to do something like this, first try, told you. Sorts and nubs, Tony, thank you so much. I told you, I put in the title, first try got Cooler edition. Do I ever lie in my titles? Cup. So yeah, that was actually super fucking easy. Okay. Why is that easier than the previous problem? The previous problem was actually kind of... all right, so continue to part 2. And Elf just remembered one more important detail. The two adjacent matching digits are not part of a larger group of matching digits. Given this criterion, but still ignoring the range rules, the following are now true. Meets the criteria because the digits never decrease and all repeating digits are exactly too long. No longer meets the criteria, the repeated 4-4 is part of a larger group. Meets the criteria, okay. I think it's actually kind of easy to fix, in my opinion. Oh yeah, the performance is actually horrible in Haskell specifically. Well, if I reload this one. Yeah, why is it so fucking slow? Really? Haskell, I suppose. Wait a second. It could be because we didn't really actually compile it to native code, right? If I did something like ghc main.hs and actually compiled it and optimized it, right? Actually compiled it and optimized it, not like interpret or anything. Will it be faster? It would be like that. It's still kind of slow, not gonna lie. Half of a second. Seriously, half of a second for such a stupid task? I'm kind of disappointed in this language. And people say Haskell is faster than C. I think they're lying to me. Since somebody lied to me. I mean, 300 milliseconds. Do it in JS, it will be faster. Yeah, I'm pretty sure in JS it will be faster. If we're talking about Node.js specifically. Right, because Node.js is actually, I mean, JIT. So I'm pretty sure it's gonna be faster. Anyway. So we're gonna call this valid 1, right? So it's basically valid version 1. Let's put it like that, and we're gonna have another one which is valid 2, right? So how can we check whether a value is part of a larger group? Well, I have a trick up my sleeve, and sorry. So there is group, I think. Yeah, there we go. There is a group, right? So basically it can give you the groups and then you can actually map all of that and check the length, right? Right. And then you can filter specifically for those who are equal to 2. And if you get at least one of them, well, you're good to go. You can even do something like this, null and check not null, right? So there you go. If you have 2 exactly, it's going to be true, but if you don't, it's going to be false. So you see, we just have a one-liner that can like encode that specific criterion. I think it's kind of cool. And nobody cares if it's slow or not, okay? What matters is that you can have satisfying one-liners up your sleeve, right? So you care. Well, I mean, who actually unironically uses Haskell in the production? I don't know. It needs to be fast. Well, to be fair, I don't know how to make it faster. The only thing I can think of is to actually not use show, right? So maybe we could get rid of show somehow, and maybe implement our own show. Let's give it a try. Can we make it faster? So let's call it my show, right? And it's gonna be specifically for integers. It's gonna be optimized specifically for integers, right? It's gonna be string and stuff like that. To be fair, it doesn't really have to be show. We don't really have to convert digits to characters. It could be something like this. Yeah, I think it could be something like this. Imagine that you have this number, right? So one of the things you can keep repeating in this number, you can iterate, and you can keep dividing it by 10, I think. Right, and you can keep doing that until, well, it has to be diff, right, yeah, so you keep dividing it by 10 until it becomes 0, and you can even do something like take while greater than 0. So you have something like this. And if you map something like that with mod 10, you essentially get the digits of this original number but reversed, that you can then reverse back, and there you go, we have our own custom show that probably has one less step. Like, it doesn't convert to characters, but to solve our problem we don't really need to convert to characters at all. You see what I mean? We can even call it something like digits. I think it's gonna actually be a little bit better. So, and we can just take this entire thing, and there you go. Maybe we can even save on reverse and basically reverse all of the criterions, right? So in that way you don't even have to ever reverse anything. So you can check for increasing, right? Check for increasing, but that means you'll have to sort it in a sort of reversed order. So let's actually keep reversing it anyway. So for this thing to be like in a point-free notation, we need to replace all of these dollars with just dots, and there you go. This is the complete function. This is the complete function, and there you go. You can just put something like here, and it gives you the digits of that number. Isn't that amazing? I think it's goddamn fucking amazing, mate. Alright, so what essentially we have to do next, we have to replace a show with digits, and I think it's gonna be pretty much the same. And if we try to do a main on that, it's still fucking slow. I think it's even slower than it was before. Yeah, it's even fucking slower. Well, there you go. How impressive is that? How impressive is that? I don't know. Yeah. So let's actually, well, I mean it. Let me do that. Wait a second. I think it's faster. I don't know what exactly happened, but it feels like it's a little bit faster. Okay, let's actually do optimized compilation, right? Optimized compilation and see how fast it's gonna be. Boom, and it didn't improve performance at all. As a matter of fact, it made it worse. So there we go. It's still extremely slow. And the question is, why exactly is it slow? It could be because of nub, by the way. Could be because of specifically nub, because it's square. Yeah. Whatever. Our goal is not to make it fast. Our goal is to make it first try. That's our goal. Okay. So if it first tries, we succeeded. All right. So we're still gonna have is increasing, and contains double group, right? Contains double group. So is increasing is gonna be the same. Is increasing is gonna be the same, but contains double group. Contains double group is gonna be this thing, and so we're accepting S here, and I guess that's the entire thing. I think that's the entire thing. So yeah, so I'm gonna replace this stuff and reload everything, and there we go. Let's see what's gonna happen. 710. So this is the new criterion, and let's just put it into the answer hole. First try that, mother flip. How about that? Another first try of the stream. Easy. All right. So, well, the problem by itself is super easy. I mean, there's nothing to solve here. Okay. So let's actually clean up some stuff, right? Let's actually clean up some stuff. Let's have a function that accepts a validation function, right? And gives you the answer. It may also accept the range, right? It may also accept the range, low and upper, and then the validation function, and yeah. So this is going to be low and high. And essentially what we're doing here, we're using this expression. This is low, this is high, and that essentially returns us the answer. So I also want to print it appropriately, so I'm going to do text printf, right, text printf, and it's going to be printf part 1 as, not d, not as, d. Solve, I lost my range. I lost my input. Give me my input. Here it is. So let's actually literally call it input. Alright, it's gonna be input. Boom. Like this. This is not what I want. Solve input is valid 1, and the second one is gonna be is valid 2. There we go. And of course, the classic Zozing forgot the new line. Let's put a new line here. There we go. So now you should be able to go to the folder 4 and do something like run ghc main.hs, and it will compile everything and it won't work because I don't know why. Length does not return. Yeah, you have to do. To be fair, you have to. Wait, what? You filter with is valid, and then you take the length of it. And what does it say? Oh, it also has to. Okay, is valid. I see. I'm an idiot. I see. So I'm really sorry, chat. I'm really dumb. I'm not smart at all. I don't have a PhD in computer science. Look at that speed, violence, momentum. Isn't that amazing? That's the language we deserve. That's the language we deserve. Mein Gott. Absolutely fucking amazing. The language that competes with C in some cases. Absolutely amazing. Anyway, rewrite it in C. I don't want to do that. I'm sorry. Okay, let's also document everything. So maybe I'm gonna remove all of this shit. So it's gonna be read me. Day for solution, and the day for day, we're gonna refer to this day, boom, and then we're gonna have expected result. It's gonna be console, hola, and let me put it right there. It's faster than C if you never implement the C version. I don't think it's a correct statement. So if you want to compare it with C, you have to have this object you compare with. If the object you compare with does not exist, I don't think you can say they're comparable. At least to me, it doesn't make much sense. I'm sorry. Alright, so yeah, let's actually do a committee. For add day for solution. Okay, and let's actually push that right into the repo. You can find the source code of the solution right there. Yeah. So we're moving to a day 5, which is probably gonna fuck us in the ass, because I think they're just sort of like trying to debate you with the easy problem, right? They're trying to debate you. How did you learn Haskell? I was programming in it. I didn't really watch any videos, books. Well, I did use Google a couple of times. Actually, a lot of times. Usually I learn things by just implementing something in them, and if I need to do something, I just Google specific thing. All right. So, day 5. Are you guys ready? There we go. Sunny with chance of asteroids. You're starting to sweat. You're starting to sweat as the ship makes its way towards Mercury. The elves suggest that you get the air conditioner working by upgrading your ship computer to support the thermal environment supervision terminal. Test. It spells test. Okay. Okay, so when they say that on the next paragraph, okay, cool. Test starts by running diagnostic program. You puzzle input. The test diagnostic program will run on your existing int code computer. We implemented that shit. Ooh, that's so cool. Yeah. So the problem actually cross-reference each other. The plot thickens. Okay, first you will need to add 2 new instructions. Opcode 3 takes a single integer as an input and saves it to the position given by its only parameter. For example, the instruction 350 would take an input value and store it at address 50. Input value. Okay. Opcode 4 outputs the value to its only parameter. For example, the instruction would output the value at address, but where does it output? Okay. A program that uses this instruction will come with documentation that explains what should be connected to the input and output. The program outputs whatever it gets as an input, then halts. Second, you will need to add support for parameter modes. Ooh. Parameter modes. Each parameter of an instruction is handled based on its parameter mode. Right now, your ship computer already understands parameter mode 0, position mode, which causes the parameter to be interpreted as position. If the parameter is 50, its value is the value stored at address 50 in memory. Until now, all parameters have been in position mode. Now, your ship computer will also need to handle parameter in mode 1, immediate mode. In immediate mode, a parameter is interpreted as a value. If the parameter is 50, its value is simply 50. Okay. Parameter modes are stored in the same value as the instruction opcode. The opcode is a 2-digit number based only on the ones and tens digits of the value. That is, the opcode is the rightmost 2 digits of the first value in an instruction. Oh my god, is that like a similar to how x86 works and encodes its shit? I think it is. Right. So parameter modes are single digits, one per parameter, read right to left from the opcode. The first parameter's mode in the 100 digits. The second parameter mode is the thousands digits, and the third parameter mode is the 10,000 digits, and so on and so forth. Any missing modes are 0. For example, consider the program 1002. So, okay, this is the operand 2, I suppose, and this encodes the mode of some sort. This is still better than x86, I can imagine, okay. Alright, the first instruction is multiply instruction in the rightmost 2 digits of the first value 0 to indicate opcode 2 multiplication. Then going right to left, the parameter modes are 0, 100 digits, 1000 digits, and 0, 10,000 digits not present in and therefore 0. Alright, okay, first parameter mode. So this is the opcode, right? This is opcode, 2-digit opcode. And here we have the mode of specific parameters, so you can have different modes per parameter. Okay, then I see. So it basically encodes how to interpret a particular parameter as the value or as the pointer. Simple, easy. Okay. Yeah, position mode, immediate mode, position mode, immediate due to being a leading 0. Makes sense. Makes sense. So we will have to extend our machine to support all of that bullshit. Yes, we'll have to support all of that bullshit. This instruction multiplies its first two parameters. The first parameter 4 in position mode works like it did before. Its value is a value stored at address 433. The second parameter 3 in immediate mode simply has value 3. The result of this operation is that, okay, it's written according to the third parameter 4 in position mode, which also works like it did before. 99 is written to address 4. Architecture that makes sense. Yeah, I suppose. Parameters that an instruction writes to will never be in immediate mode. Okay. Finally, some notes. In parameters that an instruction writes to will never be in an immediate mode. Yeah, because otherwise it just doesn't make any sense, right? It has to be an address. Finally, some notes. It is important to remember that the instruction pointers should be increased by the number of values in the instruction after the instruction finishes. Because of the new instructions, this amount is no longer always 4. Integers can be negative, All right, is a valid, store the value in position 4. The test diagnostic program will start by requesting from the user the ID of the system to test by running an input instruction. Provided one, the ID for the ship as air conditioning unit. Oh, okay, so I think I understand. I just need to catch my breath, and yeah, then we're gonna continue reading what's required from us. I'm also thinking about actually extracting the machine out of the problem into separate module that can be reused across several problems, and maybe speeding up the machine. So I have a couple of ideas on how to make it a little bit faster. We will explore that. That may require third-party dependencies, but I think in case of a Haskell, they could be justified, because I would imagine that the further we go in problems, the slower our machine will become, the slower the program will become, right? Because they will probably become more and more complex, and we do need an, you know, an efficient machine. On the base, we'll see about that. We'll see about that. Okay, the test diagnostic program will start by requesting the user ID, the ID, input provide it 1, the ID for the ship's air conditioning unit. It will then perform a series of diagnostic tests confirming that various parts of the int code computer, like parameter modes, function correctly. For each test, it will run an output instruction indicating how far the result of the test was from the expected value, where 0 means the test was successful. No 0 outputs mean that a function is not working correctly. Check the instructions that were run before the output instruction to see which one failed. That's actually pretty cool. Finally, the program will output diagnostic code and immediately halt. This final output isn't an error. An output followed immediately by a halt means the program finished. If all outputs were 0 expected the diagnostic code, the diagnostic program ran successfully. After providing 1 to the only input instruction and passing all the tests, what diagnostic code does the program produce? Ooh, that's really fancy. I like that. I really like that. And how huge the program is? It's actually a pretty significant one, I would say. Yeah, it's pretty cool. Can you code in Lisp? I don't know what is Lisp. What is that? Is that a programming language or something? Probably. I don't know. I don't really know that many programming languages, unfortunately. I only know Haskell, so it's like the only one that taught me in uni, right? So it's just they never taught me anything else, and that's why I can't find any job. So because I only know Haskell. Okay, 05. Okay, 05, and let's go. By the way, I forgot to update the title. Oh shit, I'm sorry. So it's a day 5 now, right? It's a day 5, and Yizu. And if we take a look at the project, right? If we take a look at the project, we also need to update these things. So it's going to be update CMD project. It's going to put it here, and it's going to be a FIFO. There we go. A boom. Is it going to work? Yeah, it worked. Cool. Now I'm going to go to main.hs and chat. Look, there we go. Can your Vim do that? Can your Vim do that? I don't think so, actually. Your Vim can do shite, boy. Haha. So that's the whole program, as far as I can tell. So where did we define the virtual machine? Oh, here it is. Here's the virtual machine. So I'm thinking, how can we extract this entire thing to a module? Well, obviously we'll need to create a separate module first. So how are we gonna call this machine? Does anyone know how should we call it? Int code. I think we can just call it int code, right? So because it's literally called int code. Int code computer. Yeah. Int code.hs, and it's going to be module int code where, right? And main.hs. So let me see what we need here. So we have address, we have a memory, and memory is just an array. And then we have a machine that consists of memory, instruction pointer, and whether it's halted or not. You can read memory from a file, you can read a machine from a file, you can make a single step within the machine, and you can execute the current machine as it is. So I think we're gonna copy everything up until that point. So after execution, we're gonna actually put it like that. Cool. We're gonna put it like that. I think we're gonna actually export everything out of that module. I didn't see any reason to actually hide anything, so everything should be visible. And within this stuff, I'm gonna simply import int code. Might as well actually first just see if it still compiles or not. We're gonna do run ghc, is gonna main.hs, and let's see how miserably it fails. It actually fails quite miserably, just like my life. So now I'm gonna do import int code, and let's see if it's gonna improve it. Dithinur, welcome to the stream, and Nutrix Life also, hello. Really glad to see you all. So let's try to run it one more time. Isn't gonna work. It didn't fucking work because it needed all of these like text things, right? It needed all of these text things. I mean import things. Right, is it gonna work now? Is it gonna work? On top of that, it also needs overloaded strings. Without overloaded strings, it doesn't really work. So let's put it like that. And I think it's doing things. So, and in the original example, we expect exactly these results. I think it's kind of amazing. Cool. So, and to be, for this machine to be reusable, I think we need to move it somewhere, maybe move it outside of this folder to the root. Right, so we can try to do that. And of course, that is going to break the current, program. Is there anything like include path in GHC? I don't really know. So let's actually take a look at the help and waste a half of an hour trying to figure it out. So include, does it have something like path? Okay. GHC search for modules. I'm finally wearing my glasses instead of my contacts, and I'm not used to moving my head instead of my to be fair, I don't even know what it's like to wear contact lenses because I never wear them in my entire life. I'm too scared to put anything into my eyes, so that's why I always wear glasses. File names and separate compilations. So, all right. The search path. Okay, so we can do I. Yes, nice. Okay, go. Glasses gang. Yeah. So we can do something like this now. Is it gonna work? Yeah. It worked. It's amazing. I really like that. So, and then I can just run this entire thing. Cool. Can I now also do run GHC? Oh, we have a raid from One Lives Left. Thank you for the raid, and welcome to our Advent of Code session, I suppose. How was your stream, by the way? Did you manage to fix all of the Unicode bugs in your program? Unicode is hard, by the way, so yeah. I think when for my bot, when I was actually implementing the emote handling, I think I had a similar bug where I just didn't realize that the Unicode would offset the positions of the emote or something like that. Yeah, you killed Unicode. Okay, that's a good decision. I mean, who needs other languages in 2020 except English anyway? So we only need ASCII, right? So who needs UTF-8, UTF-16, whatever, like ASCII? Like everyone was happy with ASCII. Why do we need all this shit? Just to be able to support these weird characters that nobody fucking uses? Like, why do we need that? Right? So, alright, anyway, let's continue. So we can do this. You can actually pass this flag to run GHC as well, so which is actually kind of cool. Yes. Now I want to go to readme and update readme slightly, because now to execute an example you have to actually do it like this, because it searches for. Do you ever use non-ASCII characters in variable names, etc.? Personally, no, but I know that it's some sort of a fetish in Haskell community, where people like to literally use Unicode symbols like arrows and stuff like that, and the Haskell compiler actually supports them. Yeah. So, but I personally don't use them, but I actually know people who do use them. It's usually like for some sort of mathematical intellectual masturbation. My cap! Get them. It actually fall too far away. Can't fucking damn it. I don't ask if people are Unicode or use Unicode very often. Yeah, it's true. Yeah, they don't use it as often as Agda people, but some of them do use it. I think in Agda, Unicode is pretty much essential to program. I'm not even sure if I think they're variants of the same things, like Unicode and non-Unicode variants of the symbols and stuff like that. Alrighty. So, okay. Looks okay, and I think I'm gonna commit all of that. So git ignore. So right now we're solving what day? We're solving day 5, right? And the thing about Advent of Code 2019 is that you sort of implement a single virtual machine throughout the whole Advent of Code, right? You have to maintain this implementation and extend it as you unlock more and more problems. I think it's actually a kind of cool idea, I really like it. So, and we reach the point where we need to reuse our virtual machine. So that's what I'm essentially doing. Extract int code machine from the day 2. And I'm going to push that right into the repo. The machine has been successfully extracted. Alright, so one way I was thinking to make it a little bit faster is to replace array with vectors, right? So arrays in Haskell are kind of slow because they're not really indexed by O of 1. They are indexed by O of 1 amortized, so that makes them a little bit slower than just regular arrays in C, of course. So you're using Zig for the whole month then? Do you ever use... okay, I'm not sure what you mean. I'm using Haskell. But I'm not using Zig. I don't program in Zig. Alright. So yeah. I think they say somewhere that the access amortized. I don't think they say that. Yeah, they don't say that explicitly. But the replacement for this thing could be vectors. Can we have vectors? I think it's just called vector, a single one. Not array, but a vector. Let me click it, please. 2. Yeah, so let's actually read about them. Unfortunately, it's a third-party dependency, but at some point it could be actually justified. An efficient implementation of int-indexed arrays, both mutable and immutable, with a powerful loop optimization framework. Yeah, that's actually pretty cool. Boxed vectors over arbitrary types. So, and this is a proper arrays that indexed with O of 1 without any amortization or any of that functional bullshit, yeah, O of 1. So it's pretty straightforward. And we can use that for the memory, and hopefully that will make it faster. But I'm not sure if it is required right now. Also, there is the built-in array type, but I don't think you can append to them. Okay. Cons, scone. Okay. You can append and prepend. Okay, very funny. Very, very funny. Well, I mean, using only third-party dependencies, I think was never part of the challenge, if I'm not mistaken. Don't quite remember, but anyway. So here is the opcode. What we need to do here is to add a bunch of more opcodes, right? So the things we'll need to add, I'm going to actually put to-dos here. To do opcode 3 and opcode 2, opcode 3 and opcode 4, and also argument modes, right? I think it's parameter modes. Parameter modes, cool. Just implement your own vector. I'm pretty sure to implement our own vector you have to write some of the parts in C, and that's kind of an explanation why it is so fast, because like I think there's C, but I'm not 100% sure. Let's actually check it out. Where is the GitHub? Where is the GitHub? Yeah, there's like a little bit of C++ in here, but it's actually header. There's not that much C++ in here. It's just some... it's just a macros. Yeah, I see. So it's a macros to use within GHC. Yeah, it's a thing. It's a thing in Haskell. In Haskell, there was no conditional compilation built into Haskell for a long time. So what they did, essentially, they just slapped CPP on top of Haskell. So you literally have a C preprocessor, like a proper C preprocessor in Haskell for conditional compilation. And you can also use this kind of macros, and it's actually the same executable. All right. 3-head or 5-head? It's up for you to decide. Is that a divine intellect? Probably. Alright, so let's actually implement this thing. So this is going to be opcode 3. Opcode 3. It's 4-head, yeah. Haha. Oh shit, this is very interesting. Look. 3 and 4, they require input and output. And the question is like, our machine is pure, like this step is pure. But if we're gonna actually make this process interactive, we'll have to return something like IO, which means that we should not make it interactive. So what I'm thinking is that we need to introduce like arrays, input and output, right? And essentially, when machine needs to read something, it will read it from this input, right? It will read it from this input. When it needs to output something, it will write it to this list. And then, after the execution, we can just inspect all of that. Just inspect all of that. And if we want to like have an interactive experience, it's since the Haskell is lazy, I think it should be pretty straightforward to make a wrapper around step, that actually like lets you interact with the machine. And the core is still gonna stay functional. Will this be lazy list? Well, so it's not gonna be even lazy list. It's hard to explain, but it's not necessarily has to be a lazy list. All right. So we're gonna have an input, we're gonna have an output, and I guess that's pretty much it. All right. So what do we have? 3. takes a single integer as an input and saves it to the position given by the only parameter. Right, given by the only parameter. Okay, so that means in this particular case we need to match the input of the machine. Need to match the input, and in the machine, like we have like halt, input, input and output. I see, I see. God damn it. So let's actually call it get input and get output. I think that's gonna be, for fuck's sake. So, and that's essentially what we're looking for. We're looking for an X somewhere here, right? So we're basically consuming this entire thing. And we'll have to do something in this particular case. If it's not gonna work, what we're gonna do? Yeah, by the way, it has to be like this, of course, whatever. The compiler will tell me that I'm using the incorrect syntax, don't worry about it. So in this particular case, we just want to crash, but it would be nice to know where exactly this kind of stuff has happened. So it would be nice to know where exactly it has happened, so we're gonna do it like that. So let's do an error, printf empty input at empty input for a read opcode at position, and we can provide the position where exactly that happened, and it happened at IP, right? So that's essentially what we want to do here, right? If you cannot read anything, so this is how it's gonna go. Next, we need to set that value at a particular position. So the only operand that we have here, the only operand is the next one, right? So here is the place where we need to save everything, right? So this is where we need to save everything, and let's update the state of the machine. So right, we're updating the memory. So we're setting x at position p, right? We're setting x at position p, and then we are updating IP by actually 2, because it has 2 parameters here, right? It has two parameters, and we also have to update input because we consumed the input. There we go. So this is how we're gonna do all that, right? We consumed the input. It's pretty neat. It's pretty neat. Okay, so can we now try to compile this entire stuff? I'm gonna go to here, GHCI int code HS, and let's see how miserably all of that fails. 32. So yeah, when we are constructing a default machine, we also have to say that we need to initialize input and output. That's true. And we're also pattern matching all of that, so which means that pattern matching is not really a feasible idea, as you can see here. Right, so something would be way better if we did it like so. Is halt. You see, it's way better, so we don't need to pattern match anything. Right. Yeah, pattern matching kind of. Oh shit! That means I have to actually put it somewhere here. I'll have to restructure it. So essentially, I'll have to have like condition guards and stuff. Oh boy! Oh boy! Oh boy! Okay. So yeah, I see what's going on. So I'll have to remove all of this stuff. And then we're gonna have a condition guard, right? So is halt machine, right? If it's halt machine, we actually, wait a second. Wait a second. We just return the machine, right? If it's not a halt machine, otherwise, Have you ever used Prolog-like languages? Never. Tell me more about them. Never heard about them. All right. So can we do something like this? There we go. So it's halt. If machine is halted, we're never gonna do anything. We might as well actually throw an error indicating that, bruh, you're using a halted machine. Why are you doing that? But maybe it doesn't make any sense. Nah. Alrighty, so here is the opcode, and essentially, if I try to compile all of that, it's gonna say that I don't have all of these parameters here, which makes sense. Okay, it's understandable. So IP is gonna be get IP of machine, right? Get IP of machine. So what else? We also need the memory. Yep, memory. Get memory machine. What else do we need? Ken Slayer. Oh my god, thank you so much for 17 months.
Ava,
Thank you for 17 months of tier 1 subscription, and welcome to our epic Sodding Pog Club. Have you noticed that we have like new emotes in chat? So yeah, Sodding Pog. It's amazing, absolutely fucking amazing emote. Enjoy. Okay, so we're also gonna have an input. Here is the input. Input. And we don't really need an output right now, so where is the compilation? Okay. And it works. Yeah. It perfectly works. Amazing. Absolutely fucking amazing. So yeah, this is the new format of the machine. And I would like to test it somehow. So let us see. So machine from file. I also need a machine like memory from file. I want a machine from memory, but it's not necessarily memory, because memory is a very specific like array, right? It's a very specific array. And what I want. From memory image, right? So a memory image is going to be just a list of integers. So yeah, so that way I will be able to just take a list of integers and construct a machine out of it, and then just run it. I think it's going to be very convenient, right? And this thing will return me, I guess memory. Let's actually do memory from image, right? And memory from image is pretty easy. It's actually access, right? And that's exactly what we do here. So here it is. You just return that, and then you do where, right? Cool. Then you do where, and that gives you the memory from image. And in here, we can now do memory from file. Let me try to compile this entire thing. And, okay, so that works. And then I can just do return memory from image access. There we go. Cool. So what's important here is that now I can construct memory from image, right? So I can, for example, take this thing, right? Just take this thing. Turn it into like a list of things, and then do memory from image. So there go, we have a memory from image, and then machine from memory, right? God damn it. Machine from memory. We definitely need machine from memory. Machine from memory. So we provide the memory, and that will construct us a machine. Should be pretty straightforward. So we provide the memory here, and essentially we can do memory from file, machine from memory. Cool. So we have like different constructors of different things for different sources and whatnot, just for the convenience. Of it. And if I try to do that, okay, memory from image, and then machine from memory, and there we go. Here is my machine. See, here is my machine. What's interesting here is this thing, according to my calculations, have to read something and put it at position 0. And 4 has to write something at position 0. Alright, so if I try to execute this machine now, execute at least one instruction here. Right, execute at least one instruction. It's not gonna work. Empty input for the read opcode at position 0. So that's kind of the problem, right? So let's actually save this machine. Maybe another thing we would like to provide here is an input. I wonder what would be the convenient way to construct such machines. So you can have memory, and you also need to provide input and output and stuff like that. I don't know, we need, yeah, so the thing is, Haskell automatically generates getters for you, but it never generates setters for you. So, and this is something that was always addressed by libraries like lenses, but we're not going to use lenses, right? So we can introduce something like set input, right? Set input, and essentially it will just accept the int and memory. So hopefully that will make it easier for us to modify. Memory get inputs equal input. There we go. And then we're gonna have something like set output, hopefully. Output, and this has to be an output. Alrighty. So once we have that, for some reason it didn't really work, because this entire thing has to be machine. Like everything here has to be a machine, not a memory. And everything here has to be a machine, not a memory. Okay, cool. So if I go back here, then I should be able to set an input with, for example, 69. There we go. So we have a memory with a program, with a specific program, and with a specific input. And if we try to step a single machine here, what it did, it set 69 at position 0 and consumed the input, and we confirmed that the machine worked correctly, and also it set IP to 2, so 0, 1, 2. And yeah, it worked. As you can see, it worked. Maybe I'm gonna implement like setters and getters for all of these things. Like, I don't know. For example, set memory would be also pretty useful. Right. So it's gonna be machine. So yeah. So memory machine get memory. There we go. So now we have a set memory, but on top of that, maybe it would be even better to have some sort of like a default machine, right? You know, empty machine, right? So and then through a sequence of setters, you will bring it to a particular state, right? You will bring it to a particular state. So it's going to be something like machine. Memory, initial memory is going to be empty, but how do you make an empty memory? So is it possible to just have array empty? I don't think you can easily create an empty array. That's awkward. Data array empty. Do you have just an empty array? We can try to do something like from list. Just an array. But you also have to specify the range of the indices, so that's kind of the problem. It has to be a range from the indices. Can it do something like that? Couldn't expect match integer, namely, yeah, it has to be something like this, 0, 0, undefined array index. Yeah, how to create an empty array? That's, Haskell empty array. Okay. So people are suggesting to use sequences. Maybe I should start using sequences as well, but I can't seem to find any way to represent an empty array. Well, okay, we can do something like this. It could be like 0, 0, and we can specify a value at position 0 is going to be just that. There we go. This is our empty array. It just has to be some sort of a memory, because you replace this memory anyway. Right, you replace this memory anyway, so whatever. Right, and then here's the memory. The IP is 0. It's not halted, and the input is that. So here's your empty machine. And then through a sequence of manipulations, you can actually set it to something, to a particular state and whatnot. So, and yeah, if you take a look at the empty machine, here it is. Here it is. Cool. As you can see, our input instruction worked correctly. So we need to implement the output instruction. So I'm gonna even do like a to-do this. All right. Implement opcode 3 for the int code machine read operation. Right. So this is the first thing we did. That didn't take that much code, which is nice. And I also want to kind of ensure that my previous solution still compiles. We would need some kind of a way to like automate testing and make sure that the virtual machine still works with the previous solutions. I think it's kind of important. I don't know why it is important for me, but I kind of feel like it needs to be done. And everything seems to be working. Okay, so yeah, we extended the machine and it still works with the old solutions. I think it's kind of nice. All right, so what's going to be the next one? Int code. Let's introduce the fourth one. For the first one, we also have a single operand, which says what we need to output. So the address of the value that we need to put into an output, right? So it's going to be something like this. No, we don't even need to do any of this. Okay, so it has to be something like p memory. We take the value at this particular address, right? We just take a value at that particular address, and we just gotta put it into the output, I think. So it's gonna be machine. So we don't even modify the memory. So what I do here is output, get output p. So it's actually value x if you think about it. Value x, append to the output, and then get IP plus 2. I think that is it. I think that's the whole thing. Yeah, cool. So if I try to now evaluate all of that, I'm gonna go to GHCI int code hs, right? And something went wrong because I never actually extracted that output. Get output from the machine. All right, seems good. So let me grab the example. Let me grab the sample. So where is the sample? Oh, there we go. So here's the machine. We step the machine, right? It sets this value to 69. Then I step it one more time. So what will happen? It will put this 69 into the output. And it put 0 here. Nice. It actually put 0 here. I don't fucking know why. Oh yeah, because we have to use it as the address. So we need to have like a next layer of indirection, right? We need to have a next layer of indirection, and now it sets 69 here. And if you step even further, it will halt. You see, it halted. Beautiful. So we implemented both of the operands here. I think that's cool. I think that's kind of cool. All right. So machine is pretty much ready. The only thing we need is the parameter modes. Cool. implement opcode 4 for the int code machine. For the int code machine, write operation, right? And let's push that right into the repo. So that these modifications for the virtual machine should be available in the repo already. And before we go into implementing the parameter modes, let's make a cup of tea. Chat is dead. Well, it is what it is. Probably I'm doing something complicated, right? And people usually just leave when they don't understand what is going on the screen. So it's just the nature of Haskell streams. There's nothing I can do about that. So, but it's a challenge. We have to continue. It's a part of a challenge. People being bored of Haskell is part of the challenge. It's not. It's just really difficult to make Haskell programming interesting. Like, making programming interesting is very difficult by itself because it's a very niche activity that majority of people are not interested in, and the only reason why a lot of people are interested in it right now is because there is a lot of hype around programming because programmers are paid a lot of money. So that's why even people who are like genuinely not interested in programming, they would still watch the streams because they think they can learn something and maybe make a lot of money and whatever. So, right. So it's already difficult to make programming stream interesting by themselves, but imagine making Haskell programming stream interesting. It's just fucking impossible task at all. Nobody gives a shit about these nerdy languages. So yeah, okay, so I'm gonna make a cup of tea. Does anyone have any questions while I'm making a cup of tea? Any questions? Feel free to ask anything. Seriously. What are you guys doing, by the way? I know you're keeping me in the background, so are you doing your work, homework, pet projects, maybe? Watching coin market cap. I have no idea what is this. What it is. You are programming a VM. Nice. Are you also doing Advent of Code or something? Doing homework indeed. I see. I see. John McFarlane will be proud of you. I have no idea who that is and I don't even care. Writing a scraper for my boss. You're scraping your boss? That's actually pretty cool. Work. Sadke. Yes. Yeah, I'm crashing out crypto at the moment. Okay. Programming from home. Just writing VM for fun. Nice. Pandoc creator. Huh. Cool. So it's kind of funny, like every time somebody asks, has anyone written any real applications in Haskell? And the only example that pops up usually is a fucking document converter, which in my opinion is fucking pathetic. So I'm not saying Pandoc is bad. Okay, don't get me wrong. Pandoc is amazing. And whoever created it like put a lot of work. But using it as the main showcase of Haskell, it's like, compare how much shit is done in C++. Fucking everything is built in C++. What is the most like well-known and most used thing in Haskell? Document converter? I guess. And again, Pandoc is amazing. That's not my point. Just saying. Anyway, I need to go to the kitchen and turn on my kettle. And don't go anywhere, or I'm gonna rewrite all of your applications in Haskell. That's right. And you'll have to maintain that. Hello. So I'm just waiting for my kiddo. Let's take a look at the parameter modes and stuff. So this is how we implement all of this, right? So there's there could be up to 4 parameters, I suppose, or 3. So this is a 2-digit opcode CBA, position mode, immediate. Okay, so and maybe the first step in implementing the modes is going to be introducing the type, right? It's going to be introducing the type position mode, immediate mode, right? So let's introduce it like that. Mode pose im. So positional mode, immediate mode. Right, and what I want to do now is parse opcode. Right, it's going to accept an integer, and it will speed out opcode, and essentially three modes. 1, 2, 3. The modes for the parameters and the opcode itself. Right, you didn't see type def. Opcode int. Right, there we go. Oh shit, there we go. So we need to implement something like this now. We need to implement something like this. Let me copy paste that and see how can we implement all of this. Yeah. So for the opcode, we need to obtain these 2 digits, right? So how can we obtain that? The easiest way to obtain that is to divide it by 100. Oh, well, modded by 100. What the fuck am I talking about? It has to be a mode. There we go. So modded by 100. Cool. So this is x. Oh, wait a second. I think we have to call it decode opcode. Yeah, decode opcode. And so this is going to be, let's call it x, and we're going to do mode 100, and that gives us this thing. The next step, we need to obtain this value, right? We need to obtain this value. To obtain this value, first of all, we have to shift this entire number by 2 digits. So in our case, shifting is division. You see, we shifted it to the right by 2 numbers, and after we shifted all of that, we can extract that value. There we go, it's 0. The next one is essentially going to be this. So the next one is 1, and the next one is 0. So this is how you essentially extract a separate digits. See what I mean here? You see what I mean? But then we'll have to convert a digit to a mode, right? So let's introduce a function called decode mode, which accepts an integer and returns you a mode. But on top of that, the mode can be incorrect, right? The mode can be incorrect. So in case of an incorrect mode, we're going to do something like error, and let's put printf incorrect parameter mode, and we can put that parameter mode here, so it would be something like x, and let's put it here. So what are the correct modes? 0, it's a position mode. 1, it's an immediate mode. There we go. Position and immediate mode. So, and in here, what we can do. So the first parameter is this one. So that means we take x divided by 100 and then take a mode of 10, and that should give us the mode of the first parameter. So we decode that mode of that first parameter. There we go. It worked quite well. So now we need to decode the next parameter, and the next one is going to be just that, and the next one, which is just that. There we go. So this is how we do all this. Isn't that amazing? Isn't that amazing? I think it's goddamn fucking amazing, mate. Anyway, so we can take our original thing and decode opcode. There we go. It doesn't work, and you know why it doesn't work? Because none of these types actually implement showable, right? So we have to do derive show and recompile yet one more time, and look at that. So the opcode is 2. The first parameter is position, so in the positional mode. The second one is in immediate mode, and the third one in the positional mode. How about fucking that, dab dab? Okay, my tea is ready, by the way, so I'm gonna go to the kitchen and just pour myself some hot water. And you don't go anywhere, or I'm gonna dab on you. So was that supposed to mean? I don't know. Hello. Man, this dude is so smart. Who are you talking about? Oh, you're talking about me? Do you even know what I'm doing? If you don't know what I'm doing, how do you know if I'm smart? Maybe I'm just spitting out some mumbo jumbo that doesn't make any sense at all, and you have no way to verify if it actually makes any sense, or if it's actually related to what I'm doing. Like, how do you know that, right? How do you know that I'm smart? Maybe I'm not. Yeah. Yeah, pseudo-intellectualism, exactly. It could be that. It could be one of those. Like, you never know. So maybe Haskell as a language doesn't even fucking exist. Seriously. Like, you don't know Haskell, how can you verify that this is a correct program? Maybe I just wrote something in JavaScript that sort of like prints all of this gibberish that doesn't make any fucking sense, and just, oh, everyone is impressed, oh, what a smart guy. So yeah. How do you know all that? Okay, so yeah, now we can actually parse different modes, the position mode, immediate mode, and stuff like that. So in pure script, Haskell is Jai. Well, Jai is understandable actually. I don't think it's that bad. Okay. Now we kind of want to be able to extract values according to their position or not. So let me show you what I mean. I want to have a function that accepts a memory, right? And it accepts a parameter, right? It accepts a parameter and the mode of the parameter. You see what I mean? The mode of the parameter, and it will return you a value, some sort of a value. Right. So let me do something like this. Obtain param. Is that how we spell obtain? I'm not quite sure. So Google, help me. Obtain, get, acquire, yeah. Obtain parameter. So essentially, if the mode is a positional mode, we're gonna treat parameter as a pointer. Excuse me. On obtain. What? Okay. So that means it's gonna be memory at param, and if it's immediate, right? If it's immediate, we don't give a shit about memory. We don't give a shit about memory, and we just return the parameter itself. You see what I mean? You see what I mean? Right. So depending on this kind of stuff, it's gonna be just that. It's gonna be just that. Yeah, I guess. Cool. Now, how can we implement all of this? How can we implement all of this? Depending on the different instructions actually may have different amount of parameters, right? And so we need some sort of like a description of each of the instruction. Alright, so are you guys ready for a little bit of a TSMR? Just a tiny bit of ASMR. There we go, here's your TSMR. Wasn't that satisfying? Probably wasn't at all. I don't know. Yeah. I kind of feel like I want to reduce this duplicate code. Just want to reduce this duplicate code, but I'm not sure if it makes any sense to do that. Okay, let's start with instruction number 1. Right, so we have an opcode, and before we can do anything with this opcode, we need to decode it. Right, we need to definitely decode it. So let's call it op. It's going to be op. Then we do opcode M1, M2, M3, and we just decode opcode like this, and that gives us that. That gives us that. Amazing. That gives us that. So now in here, what I'm doing, I'm essentially obtaining the parameter, right? I'm providing the memory, the parameter itself, like the value of the parameter, and its mode, and it gives me a new value, right? It gives me a new value, and the same thing has to go here as well. But instead it's going to be +2, and the mode is going to be 2. There we go. Yeah, and depending on the mode, as you can see, it's going to actually return different things, right? It's going to return different things, and I think that's how it's going to go. The output parameters, like this is the output parameters where it's stored. It will never be in immediate mode because it doesn't make any sense. So it's only applicable for the input parameters, right? So it's only applicable for the input parameters, I think. All right, so I wonder if we can, whatever. So let me see if this compiles, and it doesn't compile because we have param. Do I really need this this type? I feel like it could be redundant, but I can actually introduce it for some sort of a semantic situations. I'm not really sure the semantic situations of this parameter thingy, but I'm gonna just keep it just in case. And it seems to be compiling. So we need to go through all of these instructions, as you can see, and just, you know, test them out. Just test them out, I suppose. So 1, if I remember correctly, is a plus operation, right? 1 is a plus operation, and we can just craft something ourselves. So we start at 1, and for example, we can have something like this. So this is the 2 inputs, and this is the output, right? This is the output, and the inputs could be somewhere here. So it's going to be 10 and 20, and 0, 1, 2, 3, 4, 4, 5, and the output is going to be 0. There we go. So we can have something like this, and let's create a memory from image. So here's the memory from image, and then I can do machine from memory. There we go. So here is the machine, and if I step a single instruction, what's going to happen? It will take these 2 values, right? These 2 values, sum them up, and put them at the position of the instruction itself, right? And there we go. It worked actually. It actually worked. Cool. That's pretty cool. But now I need to somehow indicate that these 2 parameters are in immediate mode, right? So basically it should sum up 4 plus 5. So, and I think the way to do that is just to put 1, 1 here. And it summed up 4 and 5, and as you can see, it put 9 here, right? And we can actually mix them up. We can say that the first parameter has to be in the positional mode, and the second one has to be immediate. So that means it will take 10 and add 5 to it, so the result is going to be 15. And there you go. So result is 15. So we can actually mix up parameters with different modes and stuff like that. So it actually works specifically for the plus operation. And it's a more or less general mechanism, right? So because we decode that and just use like a level of abstraction on top of that. Does it make sense? I don't know. All right, let's continue. So this one is going to be obtain parameter. There we go. So we're obtaining the parameter, and the mode is going to be M1 and M2. There we go. Pretty straightforward. So now it should work for the multiplication operation as well. All right, so does it compile? Let's find out. So for the 3, what's for the 3? It reads the input, right? And this is destination. So as far as I know, this is a destination. So the modes are not applicable here. Modes, you're not applicable here. Sorry. For the output, I think it is applicable, right? Is it applicable? Yeah, I think it's... Oh, it's also output. It's also destination, is it not? Yeah. So it has to be like A1, right? And in here, what we do is obtain parameter from the memory, then like that, and then M1. There we go. And depending on what it is, you're basically gonna get the value itself, or by the pointer or whatnot. All right, so I think we do support modes now. We do have modes, and it doesn't even compile. Nice. Because it has to be A1. Does it work? Now it works. Cool. Our virtual machine works. Okay, so I want to go back to my solution of day 2. And I want to run ghci and just see if it still produces the expected results and even compiles. It does compile and it produces expected results. Cool. So now speaking of the solution for the day 5, so it's going to be 0, 5. And what we need to import here is int code. There we go. So what do we have? So what diagnostic code does the program produce? So essentially it will print a bunch of zeros, checking if everything is correct. What's up, Sodding2s? Welcome to the stream. Yeah, you missed how we extended the virtual machine. Alrighty. So I suppose we just need to read the input. Right, so here's the input. I can probably do that myself. It's going to be ghci main.hs. So we loaded it. Machine from file, and we're going to provide the input. We're going to provide the input txt, and here is the machine from file. And what I want to do there is I want to set the input to 1, so now it should contain the input. Oh fuck, so I have to do something like this. Okay, so now we have an input, and can I execute this entire thing? Can I execute it? Let me see. Int code. So we have a special instruction, function execute, so it executes the machine until it halts, right? And once it halts, it actually just returns the halted machine. So what we're gonna do here, we're gonna execute this machine, and then we're gonna get the output of the finished executing machine. And there we go. So we had a bunch of zeros. That were testing different things, and then we got the diagnostic code, which is supposed to be the answer. First fucking try. That was easy. So yeah, first try I got cooler. So amazing, absolutely fucking amazing, mate. All right, let me guess. Part 2. Now patch your program and run it again or something. We actually have a lot of new emotes. The new ones are Sodding Smug and also Sodding Re. So yeah, we have like these 3 new emotes: Sodding Pog, Sodding Smug, and Sodding Re. All right. Alrighty. Do I need to commit everything? I think I want to commit some stuff. Yeah, first of all, I need to actually commit the parameter modes. Where is the to-do? Here is the to-do. Okay. implement parameter modes for int code machine. The int code machine. Okay, so here is the solution. Oh fuck! I didn't actually properly do that. So excuse me. This has to be part 1. So let me quickly do that. Part 1, right? So what is it gonna be? I think it's gonna be just IO integer. So yep. Let me put it here. Part 1. Right, we take an input, we set the input like that, execute output, and then we have to get the head. Right, then we have to get the head, text, printf, part 1 d, and it's gonna be just part 1, I suppose. Is that how it's gonna go? Let's actually do something like this. So this is going to be the input and you have to produce the output, right? And what we have to do here is essentially memory from image, right? Memory from image. So this is the image, and then machine from memory. There we go. Memory from image, machine from memory. And then we can have an input, which is essentially just to read the whole file. Well, we can actually accept memory, or maybe we can accept machine. Let's accept the whole machine as well. So, and then we set the input for this thing, and we execute, we get the output, and so on and so forth. So it's going to be machine from file, and it's going to be from file input txt. So there we go. Looks good to me. So part 1. And printf didn't work. Why are you not working? Because yeah, input. Okay, so let's call it machine. Oh my god. Hallelujah. Okay. Okay, cool. So now it works. God coding, yes, I know. 05 add day 5 part 1 solution. There we go. Let's push that right into the repos. Why am I still on part 1? Because I'm not actually a God coder. I'm sorry. I lied. Okay. The air conditioner comes online. MongoTOS. It's called air feels good for a while, but then the test alarms starts to go off. Since the air conditioner can't vent its heat anywhere but back into the spacecraft, it actually making the air inside the ship warmer. Oh. I guess the designers of the air conditioner for the spaceship didn't think about that. Like, there's no air outside of the spaceship to, you know... Okay. I mean, you need some sort of like a heatsink, I suppose. I don't know. Instead, you'll need to use the test to extend the thermal radiators. Okay. Fortunately, the diagnostic program, your puzzle input, is already equipped with this. Unfortunately, your in-code computer is not. Oh shit. Oh shit. Your computer is only missing a few opcodes. 5, 6, and 7. And 8. Few. Okay. Opcode, jump if true. If the first parameter is non-zero, it sets the instruction pointer to the value from the second parameter. Otherwise, it doesn't. It does nothing. Opcode 6 is jump if false. If the first parameter is 0, it sets the instruction pointer to the value of the second parameter. Otherwise, it does nothing. Opcode 7 is less than. If the first parameter is less than the second parameter, it stores 1 in the position given by the third parameter. Otherwise, it stores 0. Opcode 8 is equals. If the first parameter is equal to the second parameter, it stores 1 in the position given for the third parameter, otherwise it stores 0. We need a instruction greater or equal for integers. That's for sure. I hope it's gonna have it. Like all instructions, these instructions need to support parameter modes as described above. Luckily, we have a mechanism for that. Normally, after an instruction is finished, the instruction pointer increased by the number of values in that instruction. However, if the instruction modifies the instruction pointer, that value is used and the instruction pointer is not automatically increased. Okay. For example, here are several programs that take one input, compare it to the value 8, and then produce one output. Okay, I get it, I suppose. We can use that as a sample to test things out, I think. Here are some jump tests that take an input and then output 0 if the input was 0, or 1 if the input was non-zero. Here's a larger example. The above example program uses the input instructions to ask for a single number. The program will then output 999. If the input value is below 8, output 1000. If the input value is equal to 8, 1000. This time, when the test diagnostic program runs its input instruction to get the ID of the system to test provided 5, the ID of the ship's thermal radiator controller. These diagnostic tests should only output one number in diagnostic code. What is the diagnostic code for system ID 5? I really like this idea that you given an input which you treat as a black box, right? You treat it as a black box and you throw things into it, and if you implemented your VM correctly, it will just actually respond with something. It's just, I think it's so cool. I don't know, makes you feel like a hacker, or I don't know. So I really like 2019. 2019 was pretty cool, so far at least. I don't know, I'm on day 5, but I really like it. You Gabe, no, you Gabe. You are Gibbon. You love the rest. I would imagine how enjoyable this is to implement in like imperative language and stuff like that. But you don't like Chinese cartoons? I never said that. Okay. I actually plan to properly learn Chinese cartoon theorem, just like to the level that I understand it. So. Okay.
Keep Gabanon Cup.
Thank you so much, Rolf, for 1 year of Twitch Prime subscription. Thank you, thank you, thank you, and welcome to our epic Gaben Club. That's right, we're a Gaben fan club, I suppose. Alright. What the fuck? Chinese remainder theorem. That's what it is. So, this one. Chinese remainder theorem. Anyway. Oh boy, where is my soy? So I feel like we are given like test cases. Should we implement unit tests? Hello Gizmich, please speak English. Nobody speaks Russian here. Nobody understands you. I'm really sorry. It's kind of rude to speak other language that the majority of people don't speak. It's just like, it's really rude. Anyway, so it would be kind of cool to have some sort of unit tests that you know, constantly test the virtual machine and stuff like that. I think it would be pretty cool. Anyways, let's go and implement this stuff. So instruction number 5. So the first parameter, it says the instruction to the value of the second parameter. Okay, so that means we have something like a first parameter, right? And you're trying to obtain the parameter from a memory, and the parameter is essentially IP plus 1. Only traditional English though. I don't know how to speak traditional English. I only speak simplified. And the second parameter is destination of our nation. Okay. All right. So if the first parameter is non-zero, it says the instruction pointed to the value of the second parameter. Yeah, the value of the second parameter. Okay. Okay, so here's the value, and we have to obtain this stuff. So the mod is 1. Mod ban, permaban. If the first parameter is non-zero. Okay. If a not equal, I think it has to be like this, not equal 0, then we have to set the IP to the second parameter. So it's going to be like this. So here's the second parameter. It's non-zero. All right. Otherwise, we're going to just increment this thing. There we go. IP plus 1. And I don't think we need to modify anything else afterwards. Right? I don't think it's needed. Hello, Busy Sloth 101. I'm programming in Haskell. Have you heard about this programming language? And specifically, I'm solving advent of code problems. So have you heard about advent of code? So yeah. Haskell is beautiful. Is it? Is it really beautiful? I guess. Maybe. I don't know. So using position mode, consider, okay, for example, here is server that take one input, compare it to value 8, and then produce one output. Okay, so let's maybe test something. Do I really want to test anything? I don't feel like I want to test anything. Oh, it's actually +3. Get fucking damn it, mate. I really need to abstract this away. I really need to abstract this away. So we can introduce some sort of like an instruction description. Right. Instruction description. But it's only going to be needed in this particular place. And we sort of inlined it anyway here. Which programming language I like the most? Check out FAQ. This question is answered there. Thank you very much. Alright. So it's like at the bottom of the list. So what is my favorite programming language? Okay. Yep. Everything looks okay. 6. Alright. The first parameter is 0. It says the instruction point to the value from the second parameter, otherwise it does nothing. Okay, I guess it's pretty much like the same situation. Right, it's pretty much the same situation, but if it is 0, it sets it to that, otherwise it doesn't set it. So, alright, does it compile? Less than. If the first parameter is less than the second parameter, it stores 1 to the position given by the third parameter. Okay. So this is +3. Instruction 7. Instruction 7. So we have 2 parameters, right? We definitely have 2 parameters here, and the third parameter is the destination, right? It is in fact a destination. So memory at IP +3, right? Cool. And this is where we're gonna do the condition. If the first parameter is less than the second one, A1 less than the second one. Is it possible to have some sort of a constant here? I don't think so, actually. If I create a constant here, like hello, or maybe like plus, which is equal to 1, I don't think I would be able to use it here, because it will consider it a name and it will try to bind this value to this name, so it's not gonna really work, unless I'm using C preprocessor. In that case, I should be able to do that, believe it or not. That's the way to do that. Welcome to Haskell, by the way. Well, because like I cannot do that, like seriously, I cannot just take like +1, right, and do that, because Haskell will think that I'm trying to bind the value of opcode to name plus, and this is not what I'm trying to do. I'm trying to compare it to the value 1. So to do that, I have to actually replace it on the level of the text, and the only way to do that is use CPP. Custom parents. Okay. Haskell named patterns. Oh, you mean the add syntax? Through the add syntax? View patterns? I'm not sure what you mean, but yeah. With the guard, oh my god, guards. Like, why are you suggesting like all of these half-ass solutions? Okay, I want to have a name here, like, whatever. Okay. Guards, modes, condition modes. All right. So it's less than 1, it stores 1 at the position. Okay, so it has to be like memory / destination 1. Right, this is a destination 1. And what we do here, we take the machine memory pattern plus will work. Okay, pattern synonyms, synonyms, pattern synonyms. Just like grammar used to make them. Okay, Okay, so here is the int. It's too much text. Okay, pattern arrow. All right. So pattern synonyms can be exported and imported. Can ID. Okay, pattern P. Oh shit. Oh shit. Wait a second. That's cool. So I'm gonna put undefined here. Can I compile that? I didn't fucking know about this shit. Pattern. Oh shit. +1, right? So not in the scope. Data constructor plus. Okay, it has to be pattern P. Don't understand. Oh wait, it's a data constructor. I see. It's the problem was the naming. I see. And if I do something like this, pattern match is redundant. Okay, so that means you have to use them somehow differently. All right. So so we have P. All right. How do I use it? It's such a complicated example. Holy shit. I think I don't understand. Look, I want a really simple thing, and why like it's actually more complicated. Like it's something that you have to actually learn how to use. I don't really have that much time to learn how to use that because it looks very complicated. Holy fuck! Why it is so complicated? And why doesn't this simply works? I don't know. Okay, thank you. Maybe I'm gonna look at that a little bit later. So how is it called? Pattern synonyms. Yeah. Well, I mean, it's not that complicated. It's just like you have to invest time into reading it and understanding like this general mechanism. And I really focused on the problem, so that means I have to switch my context from solving problem to learning this weird piece of thing. So it's like why do I have to switch my context? Like I can do that, but it doesn't like looks feasible. So I'm not going to do that. But I'm going to definitely look at that after I solve the problem. So thank you for suggesting it. So at least I know that something like that is possible, but it's in a style of Haskell as usual. All right. So thank you for suggesting that. I think it's a pretty cool that you can somehow solve this problem. All right. Okay. All right. So it's less than that. We have to put this thing, but we also have to increment IP. I think, right? So we also have to increment IP. So I'm closing this thing like that. Get IP plus +3, I suppose. Let's see if it has +4. Yeah, it has to be +4 because it's opcode itself and 3 arguments. Otherwise, So memory has to be equal to that. It's actually get memory. And then here we have to put 0. What's funny is that I think we can compress all of that into a single thing, where like instead of 1 we can do if a less than a1 less than a2, then 1, otherwise 0, and I think we can get rid of this condition completely, right, up until here. There we go. Holy shit, that's actually, that looks weird, but I mean it kind of works, right? So that's a really weird thing, but yeah. Okay, so we implemented the 7th instruction, so we need to implement the 8th one. It's basically equals, so that means I should be able to copy paste this entire thing, and instead of 7 we can have 8, and instead of this we can just have equals. So it already starts to repeat, so maybe at some point we can even you know, squash it somehow, but we'll see if it will be possible to squash that. And I think we implemented all of them. So I want to write some tests. For example, here, using position what, consider whether the input is equal to 8. So output 1 if it is 0 is equal to 8. Output 1 if it is. Okay. So that's actually pretty cool. Let's take this program and put it somewhere. So I can probably put it here. So here's the thing and a memory from image. So here's the memory, and then machine from image from memory. So machine from memory, cool. Let me reload everything just in case. And we also want to set the input, right? Set the input. We're going to set the input to 8, right? So, and if we try to execute this machine, right, the output of this machine has to be 1 because it's equal to 8. Yeah, there we go. It's equal to 1. So if we input something else than 8, it's going to be 0. So anything that is not equal to 8 is 0. It has to be equal exactly to 8. So this is how we can test all of that. Isn't it cool? I think it's pretty cool. We can maybe write a bunch of tests and run them from time to time. So here's the cell programs. Here are some jump tests. Okay. Test comparison. So test comparison, and I don't know, we can do some things like it could be just IO, and we can have assert. I forgot how to use assert though. It's not insert, but rather assert. So I need to go to the Google. By the way, hello, it's plus I don't remember if I said hello to you, but hello. Assert. So it's located in control exception. So I'm gonna import that control exception. There we go. And how do you use that? Hello. By the way, I saw your pull request to BM. Thank you so much. I'm gonna look into it a little bit later. It's super cool that you implemented the whole debugger. Like Hertzplots like implemented GDB style debugger for BM. So cool. Okay, so it's gonna be control exception, and let me take a look at the assert. What does it accept? So it accepts Boolean and then just a value and returns that value. Okay, that makes sense. So that Boolean is going to be essentially, we can just set the output, right? So here's the output. Oh my god, Zalien 00.
Zodinphilus.
Thank you so much for 3 months of Twitch Prime subscription. Thank you, and welcome to our epic Zodin Feels Club. That's right, welcome. Pog, Zodin Pog indeed. So after that we just need to compare these things, I suppose. What would be the easiest way to compare? we can have like a triple, right? You have a program, right? You have a program, then you have an input, and then expected output, right? So you have something like this. Then you can have something like this, right? Where you have 7, which has to be 0, and 10, which also has to be 0. So, and then you can have a list of these like things, right? So we have program, input, expected output, program, input, expected output. Zozin POG, best POG. It's not bad. We actually, how much time did we spend yesterday actually drawing that? Like, yeah. We drew these emotes, or like all of these emotes, in an introvert party. And it was super fun actually. Yeah. I'm pretty sure we spent like an hour tracing the POG mouth, trying to make it perfect. What's an introvert party? Basically, every Thursday, we gather in a voice chat room on Discord, and we just do things, I guess. So yeah, that's an introvert party, essentially. Sometimes like we used to program things. It was like a local Discord streaming where people would program something. Recently we started to read articles. So essentially I or somebody else just opens some programming articles, and preferably the article has to be very triggering. So it has to be super dumb and very triggering, and we just read it and we discuss it as well. So yeah, that's what we do. So nothing special actually. Test data. But it's fun, I suppose. Okay. Yep. I don't think this it has to be like this. And then there we go. Just fail fast to succeed. Oh yeah, I remember that one. Holy fuck. Please don't remind me about it. Alright, so here's the test data, and I want to just do for m, right? So basically it will iterate with a side effect, but I don't remember how to use for m. For m, I only know how to use M4, and by M4 I mean, by the way, preprocessor. Okay, American friends, M4 is also it's also a preprocessor. Okay, so that's what I'm talking about. Yes. Okay, I'm not talking about weapons or anything like that. I'm talking about preprocessor. All right, Twitch, please don't ban me. It probably won't ban me. I'm just joking, of course. All right. So it's located in a control monad, right? Import control monad, and for m, I have to also import this kind of shit. Date control monad. So for m underscore, so it accepts the foldable thingy, the function with the monad, and I think we're good to go. All right, so essentially we have like test data, and for each of these test data, what do we have? We have a program, input, and expected output. All right, and what do we do here? We need to construct a machine first out of that. So how it's gonna go? How it is going to go? Maybe we need to print this entire thing. That would be actually kind of cool. Let's call this test cases. So this is a test cases. And this is a single test case. And what we can do here is printf as show test case. A single test case, and of course all of that is going to be in a do notation. And who said that Haskell is a pure functional language? You see, I'm using for loops in here. Like I'm literally like have a list of test cases and I'm just for loop iterating them, and within like that I'm just, you know, printing things. All right. You have to enable language extension parent for it to work. After that it is super straightforward, parent plus. Okay, so that actually makes it. So basically if you want to, like, you can do more with that, but for our case, you can just do pattern plus equal 1, it will also work. Okay, thank you. I'll look into that after I implemented the test cases. Okay. So assert. First we need to construct the machine. So memory from image, and this is the program. So memory from image, then machine from memory. Here's the machine from memory, and then the set input. We have an input, and then we have to execute this entire machine and get its output, and we get an actual output. There we go. So we got an actual output. After that, I want to do assert that expected is equal to actual, and if it is, I'm gonna do put strln okay. So that's how we do that. So you see, it just prints the test case itself, and then just checks it, and then if it's okay, it just prints that. There we go. For loops in FP. Yes, exactly. That's exactly what we have here. Sorry, it is what it is, and it isn't what it isn't. All right. So it does compile, and now I can do something like test comparison, and it was okay. Good. I can even remove some of the stuff. I can put 0 here, and if I try to do this kind of thing, comparison, it says exception asserted, and it didn't. Okay, so basically it was just not expected output. It doesn't print that much, unfortunately. I wish it would print something more, but for now I think it's okay. So there's something more for assert. There's only boolean and that. There's only like quick checking things. Okay. So for now should be okay. All right. So the next one is using immediate modes. Wait. Position mode, consider whether the input is equal to 8, output 1. Wait, what? Why is this duplicated? I don't understand. Oh, okay, so here is the single operand that is different. Alright. Holy shit. I'm gonna copy paste this thing here. Might as well do the following thing where I could do something like this. See what I mean? It's kind of difficult to like have these sections where like I could put this thing above this example, like in a comment. It's really difficult to do that because every time you try to format it, it just puts this comment above. It's so bizarre. So I always have to think, how should I even work about it? So we can do something like this. So equal, what was that? Equal to 8. So this is going to be equal to 8. All right. And our test cases is going to be just a concatenation of all of these previous ones. So equal to 8. You see what I mean? So, okay, this is equal to 8. And it doesn't even work properly. Because why? What don't you like? Program. Concat. Sorry. Provide this explanation as an argument for m. Probably. Because a single explanation, so you see we're actually, this is a single like test case, because we're just checking them outside of the range as well. So the next one is going to be less than 8. Right, less than 8, and there we go. So it's going to be that. Less than 8. We provide 8, and this thing should be false, right? less than 8. Test comparison. Okay, so it didn't work, but if I put something like 0 here, it will work. Okay, that worked. Next case is gonna be like this, and if it's greater, it's also gonna be 0, right? If it's greater, it's also gonna be 0. Okay. If it's less though, right, it should be true. So let's actually set it to 7 and then test comparison, and it fails. So it means here it has to be 1. There we go. Consider equal to 8. So it's actually immediate. So it uses positional mode and immediate mode. Okay. So let's actually do it like that. So this one is a position mode. This one is also positional mode. Okay, equal to 8, and I think I'm gonna just use the same thing here, but I'm gonna swap out the program. This is actually very interesting. If program is possible to swap out, I can do something like this, program equal to that, because it's a duplicate of the program, if you think about it. Look, I can do something like this, program, and put it like that, and then put an in here, and if I align everything correctly, it may even work, but of course it is Haskell, it is not going to work that easily. Oh my god. I wish it would just work, it doesn't. Did I really fuck it up? I think I really fucked up something. By copy. Okay, so I see what I fucked up. Can I do it now? There we go. So you see what I mean? Right, and we can even have an explanation. We can even have an explanation here too. Description. Right, so here's the description, and the description could be one of those things. Emacs, please. Okay, thank you, Emacs. All right. All right. So this is going to be that expected program description. Cool, nice. Holy shit, it's so hard. Okay, so we have a program and a description. It's gonna be too much. It's just probably, not sure. All right, so another one, let program, and let's actually bring this thing here, and it's gonna be a program, right, and it's gonna be that, and we're gonna put in here. Cool, that's very interesting. Writing your own test framework, probably, not sure if it's a good idea, but it's interesting nonetheless. So, and then description is going to be like this. All right, and so that means here description. Cool. We'll see if it's. I don't like this idea because I don't know where to fit such a huge description. It's too huge of a description. Really don't like it. Okay. All right. Just make it shorter, Zozin. Zozin, why are you still on part 1? Are you dumb, Zozin? Alright, program. There we go. Cool. Description. Okay, and this is the... so this is immediate one, but I probably fucked up already here. So we're not gonna put this one yet, right? We're not gonna put this one yet. So we only have these things. So this is like a single block in here. So this is a group. Test groups. So a single test group and test group. I'm not sure if I even need that, because in here, then later I can do a description. Right. So then what do? I do, hopefully, printf s n description. Might as well actually just do put strln. So here it is, description. Oh shit. So if it's a single group, right? If it's a single group, we might as well do the following thing. So it's going to be program description and just expected input output. Just expected input output. I think that's what we can have here. All right. So, and this is going to be our thing. Yeah, like this, I suppose. I suppose this is how we can approach that then. Okay, so, all right. So I'm just changing a lot of things because I'm not sure what's going to be the best approach to organize all of these things, right? This is a design process, by the way, for all of you who never encountered anything like that. This is how design process is happening. All right. Because people these days, like, they expect you to write like everything first try always. Like, it's not how it works. I'm sorry. You actually experiment a lot, and you do all of these interesting, weird things. And the process by itself is also very interesting, in my opinion. All right, so there we go. Cool. And then we can probably do something like this. This is how you do multiple, like multi-line string literals in Haskell. It's really dumb. Yeah, so you have these kind of groups. Yeah, there we go. Now we're already starting to get backseaters. Yeah, sure. Just use HUnit, just use quick check, whatever the fuck people come up with. Sure. All right, test group. Right, so test group consists of a program, program description, and the cases, I suppose, test cases. All right, so we put the description there, and we'll put the program, I suppose. Let's put printf description. Right, here's the description. Program. It's gonna be show program. Okay. Description, show program, show cock. Okay. Now we need to iterate through the cases, right? For m, test case, and what do we have here? We're gonna have an expected, right? So input, if I understand correctly, right? And expected output, right? And an expected output. And in here, what do? We repeat this entire thing. It's gonna be printf, where I show the input. Okay, so printf space input s. I'm gonna show input expected, and then we need to calculate the actual. And I think I accidentally removed the actual, so we'll have to calculate it one more time. So do I have the actual calculation still left somewhere? I think I do still have that. So, and essentially this is how it's gonna go. It's gonna be equal to, right, so memory from image, I have to use the program, then I have to use the input, there we go, execute, get the output, here we go, actual output, cool, actual output, and then we assert expected and actual, and maybe we can even print something like actual s and just show the actual output. So this is going to be our way of doing all of that. Wonder if it's going to work. I don't know. Let's try to compile this entire stuff. It doesn't compile because instead of test case, we have to use test cases. And what else do we have here? So description didn't work. That's really strange. So it's supposed to be a string. And what does it say? Variable printf is unresolved, blah 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 blah. I don't understand what the fuck they want. What did I miss? Here's the description. Right, so I'm taking it as a second argument here, and this is in fact a second argument, and this is a string, so it should be possible to put that thing there. But it doesn't work because ambiguous type T0 arising, like it's not really ambiguous to be fair. The only problem I can see is that it doesn't know whether it's a string or a text because we have overloaded strings enabled. So that could be the thing. So to fix that, we can do something like, to be fair, we only need to hint it once in a single place. All right, let's actually put it like this. Test group, and test group is a tuple that consists of the input of the program, right? Consists of the program, description, which is just a string, and a pairs, like a list of inputs, which is like this thing, right? Which is like kind of like a cucumber something. I don't want to do that. The easiest way to hint is just to put string in one single tab there. You know why? You don't even need to put this thing in a second one, because both of these things will be put into a single list. So the fact that you use string there will implicitly mean that you use string there. Otherwise, it won't be possible to put this thing here. So yeah, basically Haskell is not powerful enough to understand. Well, I mean, this expression is too abstract to know what kind of strings I mean here. So if I try to recompile it, now it works. You see? So you don't even need to hint it in the second one, because we enabled string overloading, and because of the string overloading, string literals can be inferred to different string types. It can be inferred into the string or inferred into the text, or maybe you custom string type. So this is like the price you have to pay for this feature for overloaded strings. Sometimes you have to hint this kind of stuff. Byte string too, yeah, it's like you can even define your own custom strings if you want to. All right, so this is how it works, and if I try to test comparison, there you go, this is what we have. Cool. So it would be kind of nice to also maybe have something like a little bit of more separation between the test cases, right? So we have a description and a program. Yeah. Cool. Yeah, I guess that's what we can have here. Cool. So less than pause. So in here, the next one is going to be equal to 8, but uses immediate mode, right? It uses immediate mode. Right, equal to 8, but uses immediate mode. Let's replace the program with this one. Okay. So it's gonna be like this. Cool. Nice. And I'm gonna add this thing here as well to the test groups. Cool. It seems to be passing. If I modify something here, I'm pretty sure it's gonna fail, which is, yeah, input expected. I think we should print actual always. Let me try to do that. Yeah, actual should be printed always, and here another thing we want to do is to print okay if something went okay. Print strlen. Okay, so this is how we're gonna approach that. So that means I have to put it somewhere here. There we go. Cool. So expected 1, actual is 0. So that's cool. It gives us as much information as possible, which means, yeah, there we go. Cool. Description, program, blah, blah, blah. Cool. So less than 8 immediate mode. So in the immediate mode, we're gonna do something like this. Cool. What the fuck happened? Why is it like that? Alright. So, alright. So in immediate mode, it's also like this. Cool. So we put all of that into the test cases. That's actually pretty interesting. So, and over time, I think we're going to develop our own test framework out of that. Some jump tests that take an input and then output 0 if the input was 0 or 1 if the input was non-zero. That's really interesting. Here's a larger example. The above example program uses an input instruction to ask for a single number. The program will then output 99 if the input value is below 8 and output 1000 if the input is equal to 8 and 1000. Okay. Let's put these two things into the test case as well. So this is just a test comparison, but maybe we should just call it simply test. Yeah, I think it's a little better. Just test machine, just go through all the tests. And this way we can always be sure that it doesn't fuck up something very important. You didn't add the latest to the group. Oh, fuck. Less than 8. Maybe I should also inline them. Yeah, I think it would probably make sense to just simply inline them as a single like array and stuff. Okay, seems to be working. So if I inline them, I never, but then it will be very unreadable. So I don't really like that idea. Yeah. So let's define a group. Let's define another group. Jump position mode. So the program in this particular case is going to be this. So here's the program that we're using. Okay, so description is take an input, then output 0 if input 0. Okay, right. So this is the description. Cool. And let's introduce the test cases. So take an input, then output 0 if the input was 0 or 1 is okay. So if the input is 0, we expecting 0, right? So this is what we're expecting. I'm gonna put 1 here. So this is jump pause, right? So this is gonna be jump pause. Cool. Test. So expected 1, but actual was 0. Okay, so it has to be 0 here. I think this is what description implied. And yep, it worked. And another one, if it's non-zero, like if it's 1, it has to be 1. Right? Okay. And if the input is 2, it also has to be 1, right? But we're gonna put 2 just to test if it fails. Yeah, okay, so that means it has to be 1. Cool. So, yeah, people were asking why I'm not doing TDD, right? There we go. Well, I mean, TDD implies that I write these tests first, and then I implement the behavior, but yeah. So this framework starts to grow into something. It becomes really convenient to add things here. So the jump pause, right? So this one is going to become immediate mode, right? And let's actually add that jump immediate. All right, and the program has to be slightly different, right? So for the immediate mode, this is going to be the program, right? So a boom, and I'm going to just remove all of that. So this is a jump immediate, and do we have that? Oh, and the description has to be different for these two. Take a movement, position mode, immediate mode. There we go. Cool, everything seems to be working. So here's the larger example. The above example uses the input instruction to ask. So basically it's a combination of all of them. All right. Yeah, I see. All right. Let's see. Jump and CMP, maybe CMP and jump. So this is how we're gonna call it. So the program is gonna be huge. So let's put it there. There we go. It doesn't really even properly do. Oh shit, that was a bad idea. Holy fuck. Okay, how am I supposed to then... Oh my god, this is gonna be such a pain in the ass. Alright, okay. Instruction to ask for a single... The program then will output 99 of the... Oh my god, okay, whatever. Testing, comparison, and jumps at the same time. This is what I'm gonna put here. So what's gonna be the first input here? So I'll need to put CMD and jump, CMP and jump, right? CMP and jump. Right, so here's that, and this is really bad, look at that. But I mean, this is how my formatting program actually does that, so there's nothing I can do. If the input was below 8, okay, so I'm gonna put like 7, and I'm gonna put just 69 here, right? So it will fail, and this is exactly what I want to see here. So this has to be at least. So, and if I do that, the actual is 99. Okay, so it is in fact 99. Cool. And if I test that, so if it is equal to 8, it's going to be 1000. Any plans on moving the test to another file? Why is that important? What if I'm going to work on an operating system that doesn't have a file system? Have you thought about that? Huh? Okay, so if it's above, right, it's going to be 1001. Cool. Okay, so all of the tests pass. We lost a lot of people, right, because they probably think that I'm doing something useless, but in fact, I'm doing something important. So this is, by the way, one of the reasons why I started to explain, like, you know, sometimes it is okay to remove the thing that you're working on because you're experimenting and trying things, but majority of people don't care. The majority of people don't give a shit. They think if you like trying and removing, that means you don't know what you're doing, and we actually lost a lot of people because of that. So you active chatters may say how much times you want that. It's okay, we understand. No, majority of people just don't understand. Like, it's just, they just don't understand. But we ended up with a pretty cool testing framework that is going to be actually useful throughout the development. So yeah, and we may finally continue. Finally continue. So, and because in the future we're going to actually add more features to this machine, and having this test is going to be super useful. Okay, this time when the test diagnostic program runs, its input instruction to get the ID of the system to test provided it 5, the ID of the ship, and this diagnostic test suite only outputs one number, the diagnostic code. Alrighty, so I'm gonna go to the part 5, day 5, and I'm gonna implement just simply part 1. You know what? You can actually simplify it even further. You can like provide the list. Maybe even like a single number here. So this is going to be a machine and the ID identifier. Like ID is already taken, unfortunately. Right, ID is already taken. So we're going to put it here. So this is identifier, and we also take the machine. There we go. And we need to call this solve, right? And when we're solving, effectively, right, we just do 1. And for the part 2, we have to use ID 5, and that should be it, believe it or not. That should be it. We can now go to the 05, GHCI, right? And let's just print. Oh my god, it didn't work because it has to be just that. I forgot that I decided not to do that. Okay, main. So this is the result. How about that? Isn't it cool? First try. And I'm not sure if anyone noticed, because probably everyone is just keeping the stream in the background, but we solved it first try. was actually super easy. So yeah, we completed day 5. Actually completed day 5. Alright, let's try to commit all of this shit, I suppose. So let me try another thing. Probably. So I'm gonna include that. So we implemented opcodes 5, 6, 7, and 8. Alright. Implement opcodes 5, 6, 7, and 8 for int code machine. Cool. Oh fuck. I included the tests. I wanted to commit them as a separate commit. Okay. Reset head -1. Okay. I have to be a little bit careful. So it's actually smashed together in a single hunk, and I thought that they would be split into separate hunks. So that means I have to select them separately, unfortunately. It is what it is. Alright, one more time. Implement int code opcodes 5, 6, 7, and 8. Right. Introduce tests for the int code machine. I will introduce the tests. And yeah, full solution for the day 5 problem. And also we need to probably add the readme, right? So expected results and stuff like that. It actually was pretty fast. So, but the program itself that we're using for the input is not that big anyway. Well, it's relatively big, I would say. But yeah. Okay. So let's write the readme. Readme md day 5. And let's give the link to the day 5 in here, solution, and expected result is gonna be console, and let's put this thing here. Cool. Let's put this thing here and add readme to day 5. Solution, let's push that right into the repo. Boring stream, am I right? Absolutely fucking boring. Fucking language for nerds. Who's interested in that? Alright, return to Advent of Code. Yeah, I think I want to make a small break because I really need to pee. So after that, you know what? I'm gonna first prepare the tea and then I'm gonna pee. Does anyone have any questions? Maybe somebody is interested in something about Haskell or Advent of Code or problem solving or coding in general. So yeah. Were you spoiled about 2019 AOC already? Well, I know that you're gonna use this machine throughout the like Advent of Code. That's the only spoiler that I have so far. I'm a noob in programming and learning C++. Okay, that's not really a question. Hello, Mr. Bowtie. Welcome. Is 2019 AOC harder than 2020? I don't know, depends on how you measure the hardness. How do you measure the hardness? How do you want to measure them? I personally like 2019 so far a little bit better, but it has nothing to do with difficulty of these problems. Teach us TDD. I already taught you. I already showed how to do that, so you should already know that. Hardness, yeah. I meant difficulty. I'm sorry. English is not my first language, so sometimes I say weird stuff. Alright, so let's make a small break, I suppose. Mm. Mm-hmm. Okay, so let's make a small break and you guys have fun. Oh, let me actually put it 3 minutes because I think I'll need to take some time to also put some water in the kettle and turn it on. Yeah, have fun. Alright, welcome back. I swear to God, once I'm done with this AUC, I'm never streaming Haskell ever again. Waste of time. Alright, so yeah, I'm waiting for the kettle. So let's start the day 6, I suppose. Let's start the day 6. Universal orbit map. So you've landed at the universal orbit map, UOM. COM. Center of mass. Why not COM? But how would you translate COM? I don't know. So you've landed at the Universal Orbit Map facility on Mercury. Because navigation in space often involves transferring between orbits, the orbit maps here are useful for finding efficient routes between, for example, you and Santa. So I'm not the Santa. So who's the Santa then? You download a map of the local orbit, your puzzle input. Except for the universal center of mass, every object in space is in orbit around exactly one other object. Except for the oh my god, I need to read again, I don't understand what the fuck is going on. At the Universal Orbit Map facility on Mercury, because navigation the orbit maps here are useful for finding efficient routes between, for example, you and Santa. You don't with your puzzle input. Okay. Except for the universal center of mass, every object in space is in orbit around exactly one other object. An orbit looks roughly like this. Okay, so... And also there's a universal center of mass. It's like basically the starting point of everything. So around which like everything rotates, I would presume. In this diagram, the object BBB is in orbit around AAA. Yeah. The path that BBB takes around AAA, drawn with lines, is only partly shown. In the map data, this orbital relationship is written AAA BBB, which means BB is in orbit around AA. Before you use your map data to plot a course, you need to make sure it wasn't corrupted during the download. To verify maps, wait a second, so essentially the objects form a tree and you need to check that it is still a tree, right? So if something got corrupted, this relationship won't form a tree, right? So is that the problem that we're trying to do here, I suppose? So you need to make sure it wasn't corrupted during the download. To verify maps, the Universal Orbit Map Facility uses orbit count checksum, the total numbers of direct orbits, like the one shown above, and indirect orbits. Oh, I see. So, you know, how to say that? Transitiveness. Transitive flow or something. Yeah, I see. Whenever A orbits B and B orbits C, A indirectly orbits... Okay, it's really straightforward. This chain can be any number of objects long. If A orbits B, B orbits C, and C orbits D, then A indirectly orbits D. For example, suppose you have the following map. Com... so it starts at com and you have that. Visually above is a tree. Yeah, it is. It will be a tree. In this visual presentation, when two objects are connected by a line, the one on the right indirectly orbits the one on the left. Here we can count the total number of orbits as follows: the directly orbits C, indirectly orbits B, blah 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 blah. The total number of direct and indirect orbits in this example is 42. What's the total number of direct and indirect orbits in your map data? It's fucking easy, mate. Holy shit. Probably. I think maybe I can fuck up that at some point. But we just need to build a tree. Alright. Transit. Okay, thank you. M4TT 314 69 420 blaze it. Thank you so much. Alright, so let's actually update the title. Day 6. So we're doing day 6 now, right? Day 6, and let me update this thing. Alright, so it's gonna be update CMD project. Day 6, mother flipper. Boom. So it's kind of interesting that the int code machine is not used in every problem, right? It's used like between the problems. It's kind of interesting. But anyway, so let's go. Woohoo! What the fuck is going on? 06, right? Jia Yang. Welcome to the stream. Really glad to see you. Really glad to see you. How are you doing? We're on day 6, by the way. So far, we first tried like everything. I hope I'm not gonna jinx it, but yeah, so now we're just checking whether something is a tree or not. Okay. So yeah, it's pretty cool. Main HS, and I'm gonna do something like this. There we go. And also let's go and grab the input. Let me see. Get your puzzle input. How? Oh my god, it's actually pretty goddamn big. Would you look at that? 1,350 edges of the graph. Epical. Fucking epical. Alright, so my kettle's ready, so I'm gonna go to the kitchen quickly, pour myself some hot water. And yeah, I'm gonna be back. Looks like a sock puppet, which is pretty pog. Yeah, it kind of does. It kind of does. Alright, so don't go anywhere. Or what? 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 No. chat is pretty pogue today. Not gonna lie. Chat is pretty pogue. Ta-da-da. Okay, so let's go to the 6th day. GHCI, and there we go. So we can grab one thing here, and I'm pretty sure we should be able to split on this thing. And it doesn't work because we don't have such shit. So we need to import qualified data text as T, and there we go. It's a Russian way of writing relationship, right? So it should be whatever. Okay, so it's pretty straightforward. It's pretty straightforward. You see, it's pretty easy. Alt9 is back, champion of the arena. All right. So how are we gonna approach that? So one thing refers to another. Maybe we're gonna actually put all of that into the map. Why not? Sounds like a good idea. We may take, so if I do something like this, it's gonna be T text IO, right? Text IO, and if I take a read file, for example, input, right? A read file input. And it should give me a pretty huge thing, right? So it's a lot of bytes. So then I can split it by lines. I can split all of that by lines, and how much do I get? So this is exactly the amount of lines I have. So I'm gonna map each individual line here with T split on this thing, right? So I'm mapping it like that, and this is what I've got. And afterwards, I think I need to turn all of that into pairs, right? I need to turn all of that into pairs. And how is it gonna go? So I'm accepting like A and B and simply turn it into a pair. Should be pretty straightforward, right? And I can simply check the type of it. Like I don't have to like really evaluate it. I only check the type. Okay, afterwards, I'm pretty sure I need to import qualified data map as M, right? And I'm gonna reload everything. And can I do M from list? Will that produce something? Okay, so it has to be like with a dot. Yep. So, and we have a map from one thingy to another one, right? From one thingy to another one. Yeah. So that should give us the full picture, right? If I understand correctly. So what is exactly the input? The input is the map, right? Local map of the local orbits. Okay, so let's introduce the following thing. Type, not type def, but orbits, and it's going to be equal to M map from T text to T text. There we go. Yeah, I know, it's reflexes. What can I do about that? Okay, let's introduce orbits from file, and you'll have to provide file path, and it will give you orbits. That's pretty pogue. Oribit. Oribits. What is Oribits? I don't even know what that's supposed to mean. File path, and let me copy paste this entire thing here. Should be pretty straightforward. It's going to be equal, of course. File path. Cool. Let me try to recompile all that, and there we go. We have a function that builds the orbit map from the input, and we also have like a center, like a COM object, right? So central universal thingy, like COM, right? Do we even have that in here? Where's the COM? Okay, so if I read maybe orbits from file, so this is going to be input txt com object. Oh no, yes, it's a com object. And what I want to do here is I want to look up a cum, and cum is this. Alrighty. So can we just recursively traverse all of that shit and just count how many of them do we have? Yeah. Kek. Yeah, it's actually kek. I'm sorry. I just kicked too loud. Yeah, but as you can see, we're actually traversing all that. There's also like two of them. B, C. Oh shit! I think I fucked up. It has to be a multi. It has to be a multi thing. I did in fact fuck up. Okay, so let's actually do a sample. Sample txt. So, how am I supposed to be called a god coder if I fucked up this much? Alright, so let's do orbit from file, and this is gonna be the sample. There we go. And yeah, it's really bad. So essentially, first thing I have to do here is I need to group these things by a particular value. That's definitely what we need to do here. I need to group them. Alright, so let's see what we can do about that. So here's the whole file, right? So here's the whole file for the input txt, or maybe for the sample, actually. So here's the whole file. I'm splitting all of that by lines, right? I'm splitting all of that by lines. So here are the lines, and I'm mapping all of that with t split on this thing. That will give me that, and I want to map all of that with the following thing, where I just transform all of that into the pair. Right, I'm transforming all of that into the pair, and that didn't work because I forgot to do that. Okay, so here we go. Here we have these pairs. So the next thing I need to do, I need to kind of sort them by the first element. Can I do sort by compare on actually FST? So I need to compare them by the first value, right? And it's not gonna work because we have neither sort by nor on. So we'll have to import these things here. So if we try to do that, it still doesn't work because why? I forgot to use dot here. There we go. So as you can see now, we have these things like close together. So things that start with the same index, they're close together. After that, we need to group them. Can I group by? Is there something like group by? Let me see. Group by. Yeah. All right. So it could be actually done the same way. Group by compare on FST. So this is our thing, and it didn't work because it's actually probably equal on FST. I think that's what it. There we go. Alrighty. So all of the things with the same key got grouped into a single thing. After that, we need to map all of that goodness appropriately. So here we have pairs. So, and what's interesting is that we need to convert that into this kind of stuff. So we'll have to take a head of PS. We're taking a head of PS, and we will have to take the first value of it. But then we'll have to map SND for PS. And there we go. Here we have a pair B, and B goes into C and G. And after that, we need to do map to list. We need to convert that all of that into to list, or maybe actually from list. And it still doesn't work because again we have that. Okay, so now we have a map. Actually multi-map, where from one place you can actually go into two places, right? See what I mean? So, and that takes this simple expression Right, so to build all of that, that takes this simple expression. We can even use input on that, and this is how big it's going to be, but for the sample it's just easier to, it's a little bit more manageable. So yeah, having this simple expression, you can read orbits map from a file, so you will just use file path instead in this particular situation, and let's put that like this. There we go. It's pretty straightforward. Especially if you arrange it like that, it's especially straightforward, right? So let me try to do it. Right, see? Yeah, read the file, split it by lines, then map these pairs into an actual pair. You might as well, you know, like that. Yeah, it's pretty straightforward. At least there's no branching. Well, yeah, it's just like a single one-liner pipeline. So yeah, I would say it is in fact pretty straightforward. M from list didn't work. Why it didn't work? Oh yeah, because orbits is actually defined incorrectly. Okay. Cool. So I still want to align it like that. I really don't like how h-ident aligns things. I think it's really not good. Oh yeah. Look, you can treat a single line as an operation that you do on the file. So you read the file context, and here is a single individual operation that you do to get to what you want. Split by lines, each line split on parentheses, turn the list into pair, then sort them by the first element, then group them by the first element, then transform each group into mapping of ID to the children, and then turn that into a map. It's actually, yeah, it's just each individual step. It's like reading an imperative language, right? In imperative language, you have instructions: do that, then that, then that, then that, and then that. It's the same thing. It just like has a slightly different syntax, right? People are just too scared about the syntax of the language, in my opinion. Like once you break it down into these small individual pieces, it just makes sense, right? Well, I guess you can reverse order, but I'm using here like a point-free notation, which kind of doesn't really make it super easy to read. We can try to use do blocks. We can try to use do blocks. Essentially, I can put a do here, right? I can try to put a do, but I'm not going to use do blocks for lists, right? So what I want to use here is essentially like a content, right? And we're going to save the content to here, right? And afterwards, what I'm going to do, I'm going to take the content and I'm going to pipe it into the map, right? So if I remember correctly, we still have this thing somewhere. Yeah, there we go. So it's basically like dollar but reversed. Then you do it like that. Then you sort everything. You sort everything, then you group everything. And then you map everything. And then you convert everything to a map, right? Is it more readable? Hopefully it is more readable. We're about to find out. Map split on list, and it didn't work. Nice. I'm super happy about that. I wonder why it didn't work. So I would expect, oh, because I forgot to split it by lines, I see. Lines. So split it one more time. Split it one more time. This is not how we split it. Alright, is it gonna work now? No modules loaded. I guess it doesn't work like that. Oh, I have to return it, I forgot. Yeah. Well, okay, so, and then we can actually put return here because I need to wrap it back into IO. Yeah, there we go, that works. So is it better? No, it's actually from top to bottom. Right, so, is it more readable? Probably, because like it's just top bottom. All right. So, and we can even test that it actually does things. Sample txt. There we go. Looks good to me. Sort of what? Our daddy told us not to be ashamed of our code. It's from module of Prelude. I think it's from Prelude. You didn't know about ampersand? It's a reverse dollar, and I think it's from Prelude. Oh no, I think it's from data function. And I already have data function imported because I used own. Yeah, I think it's from data function. Yeah, so I saw you using the pipe operator. Like, ampersand is one of these things that's useful and everybody forgets about, actually. Yeah. For the longest time, I also used to bind, like, I also used to implement this thing myself, and I didn't know about ampersand either, so don't be ashamed of that. Like, nobody knows about this ampersand thingy. All right, so let me see. So we can do that, and the next thing we need to do essentially is maybe. Oh, can I look up this thing? So if I take this entire stuff, right, and I can try to look up. I can look up B. It gives me that. So H is not supposed to have any children. So what's gonna happen if I try to query it? It gives me nothing. Okay, that makes sense. That actually makes sense. So what we can do here now is implement a simple recursive function. So it's gonna be solve. It accepts the starting point, right? It accepts the starting point and returns you the integer, but also it may accept the orbits, right? So it will also accept the orbits. There we go. So we have orbits and object. So there we go. After that, I look up the object in the orbit map. There we go. We looked it up, and it's either gonna be something or nothing. So in that case, I'm gonna actually go very straightforward. If I got nothing, right? If I got nothing, I guess I will have to put 1. So this is gonna be the special case here. If I got just children, we'll call them access. We'll call it children. An object is gonna be, let's say, parent. Right? So we got children. What we'll have to do, we'll have to map solve orbits for these children, right? I can already use fmap here somewhere, but yeah. And then we want to sum it up. But unfortunately, is there like sum with prime? I don't think so. I think it's going to be very slow. We'll have to use like fold L plus 0 because it's going to be a little bit faster. So is it going to be like that? I think it is. All right. So let's see. Yeah, Haskell. Like, Heroes knows exactly why I'm doing that. Why is some slower? Well, it's a really long topic, so the short answer is laziness. For a bigger answer, I mean, I have to take too much time to explain how exactly it works. Yeah. Okay. Compiler is procrastinating. Yeah, it will procrastinate until it reaches the end of the list, and only then, when it reaches the end of the list, it will try to compute the sum. And while it postpones, I'm explaining that. It doesn't matter. All right. So what do we get? So I need to read orbits from file sample txt. Oh my god, no. Okay, so here's that. And I'm trying to solve that. So I'm solving that, but I'm starting from com. And it does not work because why? Because this thing is IO. So I think I need to reorder all of that because quite often quite often. Orbits is going to be under IO, so it would be, and then I cannot do it like that. God damn it. All right, so I'll have to penetrate it like properly. Okay, so here's that, and then I'm trying to solve it starting from com. I think this is how I have to do that. And couldn't match type M. Okay. All right, so if I try to do something like that, what it will give me? It will give me a function within. Is that a divine intellect? I mean, yeah, that's how it's supposed to do that. I guess it actually makes sense. And it gives me 4, which is not the correct answer, right? It's actually 42. Right. So it gives you 1, 2, 3, 4. Oh, every time it actually goes up, it increments 1. I see. So we can start from 0, essentially. And we map all of that. Then we can also map +1, right, to increment, because every time we went up, we went by 1, right? And that should actually give us something, and it gave us 11. All right, so that still doesn't match up. Let me try to count them. Like 1, 2, 3. Oh, okay, I see what's going on. Because it's a combinatorial thing, right? Because, for example, 1, 2, 3. If you have these 4, it's going to be 1, 2, 3, 4, 5, 6. I see. All right. So, well, I mean, the structure of the problem is correct. It's just like I need to think how to organize it better. I just need to think how to organize it better. Direct and indirect things. That's actually a lot, if you think about it. Okay, so if you have one path, you only have one path. If you have this one, all of the possible direct and indirect things, right, and you connect them here. But that actually may include or may not include some of these things, some of the things that connect with J, and some of them may not connect with J. It almost like feels like a dynamic programming, but it's actually on a tree, right? It's some sort of like a dynamic programming, but on a tree. So yeah, very interesting. Okay. What's interesting is that once, like if you know the length of a single path, using combinatorics, you can calculate what are the possible paths in here, right? So what you need to do, you need to calculate the length of this path, then the length of this path, and then the length of this path, and the length of this path, and use combinatorial formula on all of them, and just sum up the results, right? So basically you just need to know the lengths of all of the branches at some point. Okay, so that's doable in my opinion. It's gonna be 1, 2, 3, 4. And the question is, what is the combinatorial formula? Okay, so it's probably some sort of like a weird one, right? So in case of a 1, the result is going to be 0. In case of a 2, the result is going to be 1. In case of a 3, it's going to be... So 1, 2, 3, right, it's going to be this path, and then this path. It gives you actually 3, right, it gives you 3. So in case of a 4, right, you have 4 elements here. 4, 1, 2, 3, 4. So you have, oh, let's actually put it like that. Let's put it like that. So you have P3 for this path, right? For this P3. For this one, then you have P3 for this one. P3 for this one. So essentially you have two P3. What's interesting is that you also have a additional path that, well, to be fair, that's it. Is that it? Is that it? I don't think so. You have that, and also you have to add something. You also have to add something. It's probably going to be +1 or something like that. And I think that's what it is. Okay, so at 1 it's going to be 0. At 2 you essentially have P0 plus 1, which is 1. Okay, makes sense. 2 P1 plus 1, which 3. So on, of course. So here it is. Who needs fucking Google if you can just derive this? Did I guess it correctly? I think I guessed it correctly. Is it? Did I guess it correctly? I think yes. P2, not P. Oh yeah. So this one is P1. Yeah. P2. I don't know. Okay, let's see. All right. So let's actually take a look at that. 0, 1, 3, 2, 3 plus 1 is 6, 7. This one is going to be P5. We're going to 2 P4 plus 1. 2, 7 plus 1 is 14, 15. Okay, so what do we have? 0, 1, 3, 17, 15. So what is that? Okay. Number sequences database. So let's find out what the fuck is this shit. This is the Gaussian binomial coefficient. Number rank matroids. Okay. Is the next one going to be 31? Let's actually find out. Is the next one going to be 31? 2 multiplied by 5 plus 1. 2 multiplied by 15 plus 1. 31. Look at that. It's actually 31. So it's a Gaussian binomial coefficient. Okay. So let's actually read about what exactly it describes. What exactly it describes. Q analog of the binomial coefficient is a polynomial. Examples. Okay. Combinatorial description. Okay, instead of this algebraic expression, one can also give a combinatorial definition of Gaussian. The ordinary binomial Archimedes chooses from combinations chosen from M element set. If one takes those M elements to be different character positions in a word of length n, and then each R combination corresponds to the word length m, using an alphabet of 2 letters, so say 1, 0, and 1, then R copies. Okay, so basically you can think of ones here as ends of paths. You can think of them as ends of paths. You see? So first one is the beginning and the second one is the end. And it just checks all of the possible like connections. And this is exactly what we're counting, I think. That's exactly what we're counting. That's pretty cool. So, this is a defined. I don't know. This is how like I usually used to solve these kind of problems in competitive programming. Right. Basically, you obviously have some sort of number sequence, but you don't know what it is. You literally compute a sample of the number sequence, and then from a sample of the number sequence you can derive a formula, and then it lets you compute more of the samples, and then you can actually test different hypotheses on these number sequences. And if you have an access to the internet, you can even use the this website that I can never remember the name of, to actually read about this sequence. So this is what I do every time that I solve competitive programming. Yeah, it's actually super convenient. So if you're doing competitive programming, this is a technique that you can use. Seriously, it's so actually cool. Yeah. And people say competitive programming is useless. Yeah, there we go. So this is the thing that we're trying. Not sure how useful that is, like advent of code in general. So maybe it doesn't count. Binomial coefficient. So should be priced for. That means, by the way. Oh shit. Okay. So that means we can actually bake this formula into the recursion. How would you count the length of... I don't need to. I can calculate it as I unwind in the recursion. I can calculate it as I unwind from the recursion. So there's no need to calculate any lengths or anything like that. Yeah. So yeah, let's see. So we start at 0 and okay, so this is what I need to do here. I need to do map is going to be I, right? It's actually going to be x, and this x is going to be 2 multiplied by x plus 1. There we go. I think that's going to be the solution. And if I try to run that, I fucked it up. Did I? Yes, I think I did. It's a sample. It's supposed to be 42, the total number of direct and indirect. That is cool. I fucked it up. That is cool. Yeah. But it made so much sense. I don't know. Let me read. Maybe I misunderstood the definition. Okay. So whenever A orbits B, B orbits C, A indirectly orbits this chain can be any number of objects. If A orbits B, orbits C, okay. Usually the above example looks like this. If this visual presentation went to objects D and directly orbits C and indirectly orbits B and com a total 3L, com orbits nothing. The total number of direct and indirect orbits in this example 42. Okay. One. Not quite understanding why it would fail though. But initially it has to be 0. So if you don't have any of these things, any of the children, it's gonna be 0. Right, so I'm iterating and I'm solving them again. And for each of them, I'm stepping up. Oh shit! So I'm doing kind of a BFS approach. I see. I need a DFS instead. Yeah, because you have 2 branches here. Yeah. So let me explain. But maybe it shouldn't affect. So I'm kind of losing information. I'm losing information with all of that. So I think I'm on the right track. But the way I implemented it right now is kind of like, you know, loses information, as I already said multiple times. Okay, so imagine that you have that, and these are the these are the children, right? You found pi minus 1 from that child, and you find pi minus 1, I minus 1 from that child. Cool. So what you next do, you multiply everything by 2, and then you add 1, right? And then you add 1. But what's interesting is that afterwards, you actually sum them up, right? So we can call it left, p left, and p right. Cool. So then this is a child for another one, and for the child, and because of our implementation, pi, so this is I plus 1, and so that means it's pi, is going to be equal as the sum of these things too, these two things, and this is not correct in my opinion. Yes, this is completely not correct. So it has to be on the level of a single path. We have to find all of the like paths separately and find their lengths, right? Once we found their lengths, we can do something about that. So I need to transform my BFS-ish solution to DFS-ish one. DFS-ish? Небось. All right, so let's continue. DS fetish, yes. So we're gonna maintain the length of the path, and the accumulator. That's what we're gonna do. Length of the path and the accumulator. Is it gonna help us? Maybe we don't need to do that. Okay, let's start. Solve DFS. So it's gonna take the orbits and t text, and it's gonna return the value. So maybe we're gonna have like internal thing here. So here's the orbits, and here is the root, initial root, and we're gonna do solve DFS. Excuse me, root. Oh shit. It's gonna be prime. And maybe because of that I can actually simplify something like this. So where we have solve DFS, and we accept the root, and maybe some sort of a level, right? We're gonna accept the level, and initial level is gonna be 0. We'll see if it's gonna be 0 or not. So in that case, we're gonna look up the children of that thing. The children of that thing. Yeah. M look up root. Maybe it could be called parent. Of the orbits. Case of and if we hit nothing, we know our level. So this is essentially n, right? This is essentially n. And this is where we have to compute all of that already. This is where we have to compute all of that. To be fair, n initially can be also a value. We can compute it as we go, right? So let's actually call it answer, right? Yeah, let's call it accumulator, and we're gonna return it right away. If we got children, what do? We are mapping those children with solve DFS. Oh shit, it's gonna be actually kind of painful, but it's okay. So we take the child, right? We take the child and solve DFS on an accumulator multiplied by 2 plus 1 for the child. Oh shit, we don't have to do that, because we can literally do it like that then. Yeah. You see what I mean here? And then we should be able to sum that up. Foldo plus 0. Cool. So yeah, we're basically going deeper and deeper, incrementing the solution until we hit the bottom, until we hit the leaf, and we instantly return the solution out of it. Solve DFS. Yeah, solve DFS prime. Thank you. You see what I mean here? Right, it's a completely different approach. Like it's this one is more of a BFS-ish one, and this one is DFS. Yeah. So and we keep track of that accumulator. That's cool. I like that. And does not compile because this one has to be called BFS, because I want to still keep the previous one just in case. Right, so if now I take this kind of thing, it's even worse. Okay. I think it grows too fast. That's probably the problem here. I feel like I'm misunderstanding the problem. I think I'm counting wrong things because I don't see a flaw in my logic. I think I'm misunderstanding what they want. That's probably the problem. Use orbit count checksum. The total number of direct, like the one shown above, and indirect orbits. Whenever A orbits B and C, so indirectly orbits C. This chain can be any number. Okay, for example, suppose you have that. Visually, the above map of orbits looks like this. In this representation, when two objects are connected by the value, well, okay. Let's count all of the branches because I'm definitely just doing something incorrect. Like, the first branch here is 4, right? Oh my god, my neighbors are smoking, holy shit. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. 1, 2, 3, 4, 5, 6. This is 6. Maybe I'm counting wrong things. 1, 2, 3, 4, 5. Right, maybe I should count the edges. Maybe I should count the edges rather than this thing. I think the first paragraph under the tree is the problem. I don't think so. I think I should count the edges. In this visual presentation, when two objects are connected by a line, the one in the right directly orbits the one on the left. Well, yes, you said the same thing, but with other words. So I'm counting the objects, but I need to D directly. What? Orbit C. Okay. I'm counting the wrong things. What I have to count is the edges. Right? So I have to count the edges. So if I do one thing, well, initially it's 0, right? So when you go further, that gives you the 1. Does it? Well, okay, I'm counting the right things then, right? So this is going to be com, and then I go to the next one, and it gives 1, and the 2 multiplied by 0 plus 1 is going to be 1. The next one is going to be, 2 multiplied by 1 is going to be 3. So I don't see any problems with that. To be fair, I want to have something like P, which gives me like this. So initially P, if P is 0, it's going to be 0, right? P1 also has to be... Alright, so we have to be doing 1. So 1 is going to be 0. And anything else is going to be pi minus 1 plus 1. Okay, cool. So if I do that, it's going to be 1, 2, 3, 4. I can even do something like this, map P. And that goes further and beyond. Cool. Oh my God, I'm gonna fucking suffocate. This is not what I wanted. Okay. Now, if I decrement everything by 1 here, will that... I think I have to use spread. Will that result in what I want? It still doesn't result in what I want. Let's go even further. Maybe we can do something like -2. Okay. Is it 40? Okay. So I'm really counting something incorrect. What the hell am I counting? Yeah. Because that gives the right result, and in fact the branches that we have here are 2, 6, 4 and 3. Where do I don't see them. 2. Maybe I should just start from 0 then. So what if we start from 0? Right. Okay. That means if I... No, it still has to be even beyond that. Where... Why is it like that? Oh, maybe. Okay, so I'm orbiting that. Orbiting that. 1, 2. Okay, so the problem here is that I'm counting something incorrectly completely. So why am I counting incorrectly? Okay, I want to make a small break. So I'm really close. I'm super close. I'm on the right track. I'm pretty much on the right track, but I'm just counting something incorrectly. So I just need to figure out what needs to be counted properly. P4, is it gonna help you? Somehow, I don't know, 15 probably. Anyway, so when you have one thing here, you don't have any orbits. So it has to be 0. So P1 has to be... Okay, so if P1 has to be 1, that means we should start with 1, right? If we count in these things, right? If we count in these things, we have to start with 1. And P1 is going to be 0. If we're starting with 0 as well, okay, this is really dumb. So let's imagine that we count in the edges. 0 edges is 0. So 0 edges is 0. Cool. 1 edge is 1. 2 edges is 3. 3 edges is that. Okay. That makes sense. So when we're starting from the comb, the value has to be 0 because there's nothing there, right? So the value has to be 0. Every time we go down one level of the recursion, every time we go down one level of the recursion, we sort of increment like by 1, giving more boost into that, right? Giving more boost into that. And then once we reach a point where we don't have anything, we need to return the value. So we're gonna have 1, 2, 3, and at the point of 3, when we don't have any children, we're gonna have an accumulator with these 3 things, and that's what we're gonna have, and that doesn't give us anything. So that makes perfect sense. I'm calling everything correctly. And where is my stuff? Where is my read file? Read. Oh my god. Okay, so I lost my solution. So here is the sample. So do I have orbits from file? So this is going to be an input. txt. Oh my god, I should have actually not done that. Orbits from file. Solve DFS, like this, and then we have to start with com. Okay, it has to be returned. It has to be returned, and holy shit, what the fuck just happened? Excuse me? Oh, this is because it's yeah, it has to be a sample, of course, and it's just too much. It's just too much. What am I doing wrong? Okay, it's a tree. Maybe that can help us. Let me read that one more time. When two objects are connected by a line, the one on the right directly orbits the one on the left. Here we count the total number, just the sum of the numbers of the edges of the very each leaf. I don't understand what you're talking about. Here we can count the total number of orbits as follows. For fuck's sake. D directly orbits C and indirectly orbits B and com. A total of 3 orbits. It's not Corona, somebody's fucking smoking and I'm fucking... Holy shit. Alright. Com orbits nothing. The total number of indirects. Why does it make sense? Why? Why? What am I missing? What am I missing? I'm missing something dumb, something small. Yet again, it's one of these situations I'm missing something small and dumb. Holy fuck. But again, so the idea that if I count these things, right? If I count these things. So 1, 2, 3. So here's a 3. Next one is going to be 1, 2, 3, 4, 5, 6, 7. So this is 7. 1, 2, 3, 4, 5. Oh shit, I see. They're overlapping. So we're summing up branches of that one and of that one, and since they're overlapping, we should exclude this line from them. Holy shit. Okay, so when they're oh my god, I see, it's super dumb. Alright. So how can we take that into account? I see. So all of that works for a straight line, but when you get that, all right. So essentially you need to include that, but then this doesn't make any sense anymore. It doesn't make any sense anymore, I see. Okay. You can start from the bottom and you keep incrementing this thing up until here. And then it's going to be the sum of these two things. But at some point you have to stop. You have to stop and just basically exclude all of that. We need to mark whatever we already visited, I suppose. Yeah, it's a DFS with marking what we already visited. Okay, that makes sense. So we are DFSing right, we're DFSing up until here. Cool. And this entire branch was visited, so we already like got it included into the result. Then we go back and we are DFSing right here. So, and that also gives us the thing we want. Yeah. I wish holy fuck, I should probably switch the apartment. It's absolutely impossible to fucking breathe in here. Oh, for fuck's sake. So let's make a cup of tea. Does anyone have any questions while I'm making a cup of tea? It's actually very bad, like is it a fire or something? I hope it's not a fire. Does anyone have any questions on topic while I'm making a cup of tea, chat? Does anyone have any questions? Like I'm just making tea, I'm not doing anything. Feel free to ask any question, I'm reading the chat right now. Yeah. Thank you for the raid, by the way. Are you finished with Advent Code for 2020? Yes. You can find all of the solutions of Advent of Code AOC here. So yeah, you can find it here. Does anyone have any on-topic questions? So yeah, 2020 was an interesting challenge. Right, we used different language for each problem. Which one of your favorite problems in 2020? I don't know, I don't remember them, that's the problem. I don't remember a single problem from 2020. Like, once you solve it, you just instantly forget about it. Like, how am I supposed to remember that? Config, if you want config, you first of all can check out my dot files and also my video about Emacs. So you can check out that. Do you recommend some books or courses to learn how to build compilers? I've never read a single course about compilers or interpreters, so I cannot recommend anything. You can ask in the chat, maybe somebody knows a good book on compilers, but I've never read a single compiler book, so I don't know which one is good. Alright, so I'm gonna go to the kitchen, quickly turn on the kettle, and I'm gonna be back. Don't go anywhere. We're gonna continue solving these things. Wait, for the answer would be 6 but not 7. The problem is that branches are overlapping and we need to find the overlapping branches and exclude the count from them. You see, so it's right, so the count is not this branch plus this branch. The count is this branch plus this one. You see what I mean? Because there's overlapping here, so this segment should be counted once, but we count it twice. Yeah. We count them twice, so we have to exclude them. You don't have to exclude them. Depends on the definition of exclude. What do you mean by exclude? And what do I mean by exclude? All right, so let me see. So already visited that. Can do that. won't be the easiest way. Mm-hmm. 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 Would be easier if I had an imperative language, but unfortunately this is a declarative one, so I have to work around all of this. Mm-hmm. That's okay. But then we realize that we're doing something wrong. So I'm thinking, can I avoid doing the counts and other shenanigan stuff? Do I really have to count them, or maybe I can just calculate solution right away? Can I count them and or calculate solution right away? It feels like so far I cannot calculate solution right away, but at the same time you can always pre-calculate the values of p anyway, so it doesn't really matter that much in my opinion. Yeah, you can just have p in here and just don't worry about that. Okay. I'm just waiting for my tea. Let's actually compute that manually. Let's compute that manually. Right, so it's going to be 1, 2, 3, right? It's going to be 1, 2, 3. So it's going to give me that. Then 1, 2, 3, 4. Right, it's going to be 4, 1, 1, 2, 3. I think that's the thing we need to do. So for the 1 is going to be 1. Where is my p, by the way? For 0 is going to be 0. For 1 is going to be 1. So p is correct in this particular case. So if I take this entire stuff, will it give me the thing I want? So if I'm going to do p and then I sum it up, it doesn't even give me what I want. Okay, so that means I misunderstand it completely. It's not what I think it is. So what am I counting incorrectly then? There's still 4, there's going to be 1. What am I counting incorrectly? Alright. Okay, I think my tea is ready. I think my tea is ready. Trying to understand a think I don't understand what the problem wants from me. What does it want from me exactly? D directly counts C, indirectly B, and indirectly C. Okay. I think the formula is actually simpler than I thought. Isn't it? Okay. If the length, okay, 1, 2, 3. Okay, I think I misunderstood what they want from me. 1, 2, 3. So it's gonna be, and for that one is gonna be that. All right. L directly. Orbits K, and indirectly J, E, D, C, B, and com. Here we can count the total number of orbits as follows. The total number of direct and indirect, okay. So, I think I actually computed formula incorrectly. So, alright. So this could be essentially just one accumulator plus one, right? And at some particular point, it gives us that. It gives us that. And is that it? Is that it? No, this is not what I want. No, it's actually less than I expected. But at the same time, yeah. Okay. That, how many of these things you have here? So for D you have 1, 2, 3, basically the length of this thing. For this one is going to be 2, so you basically have to sum them up as you go, right? You have to sum them up as you go, which makes sense. So, like I really need to make this manually because I feel like I just don't understand what the problem was for me, because I feel every time it wants from me different thing, and that's the problem. Okay, 3. So 3 plus 2 plus 1. So directly that, indirectly that, and indirectly that. Okay. 1, 2, 3, 4, 5, 6, 7. Right, and you have to kind of like repeat that for each of these things. Right, for each of these things. So it has to be 1 plus 2. Oh, I see. So I also have to include that into the n. Right, so so we have all of these values. We have all of these values. And also plus the accumulator on top of that. I think that's the thing. Probably a very bad idea, but I'm gonna give it a try anyway. Holy shit, it's really difficult to actually be here. So somebody's like really smoking really hard. There we go. Okay, and if I try to do that on the input, and this could be the lucky winner. First try. Okay, backseaters, where are you all? Oh, everybody already left. We had like 160 people, and backseaters like noticed that I ignore everything they say, and they probably left. So, yeah, fortunately, we won't see their messages. Okay, so that was actually pretty straightforward. So eat that, backseaters. You think you're smart here? I want to see you try to stream that and be constantly ignored by the chat. All right. But anyway, so we don't really have that many people anyway, because people just find Haskell unreadable, right? Everyone is just scared of Haskell. So this is a part one, right? So this is just a part one, and I think it's good. Alrighty, so let's actually go to the part two. What's going to be the part two? So now you just need to figure out how many orbital transfers you, POG, need to take to get to Santa. Okay. You start at the object U. Do I really even have U? U. Oh yeah, we do have U. I didn't notice that. That's interesting. All right. Haskell isn't unreadable. It is unreadable. What are you asking for? You start at the object U. You start at the object U are orbiting. Holy shit. You start at the object U are orbiting. It's so bad. Your destination is the object San is orbiting. An orbital transfer lets you move from one object to another to an object orbiting or orbiting by other. Holy shit. For example, suppose you have the following map. Okay, cool. Visually, the above map of the orbits looks like this. Okay. In this example, you are in an orbit around K, and San is in an orbit around I. To move from K to I, a minimum 4 of the orbital transfers are required. Really? Afterwards, the map of the orbital looks like this. It's basically 1, 2, 3, 4, 5. I see. I see what you need to do here. So you start at the one that you're orbiting. This is going to be 1, 1, 2, 3, 4. Okay, that makes sense. So we can easily figure out the starting positions, I think. I think we should be able to easily figure out the starting positions. Afterward, the map of orbits is going to look like this. Cool. What is the minimum number of orbital transfers required to move from the object U are orbiting to the object San is orbiting? Between the objects they are orbiting, not between U and San. Okay, that's a pretty good clarification. Thank you so much for that clarification. It's just the shortest path in a fucking tree, mate. It's not even in a graph. It's just in a tree. So you just need to build a graph. Actually, you need to build it like a bi-directional graph to be fair. And then, yeah, sure, press it hard, I think. Okay, so let me see. So this is orbits, all right. And we want to define something like map orbits. Yeah, I want to rename this entire stuff. So this is not going to be orbits, but it's just like one directional. Orbits tree from file, right? So this is what we have. We have orbits tree from file. Do we want to separate them? Yeah, I think we want to separate them into different types. So orbits tree, and this will essentially indicate that we're expecting orbits tree from here. And then we're going to have a separate type, which is called orbits map. Right, orbits map, which has, like, semantically it has the same type. I mean, technically it has the same type, but semantically it actually like bi-directional. It's actually bidirectional, which will enable us with, you know, running a BFS, right? Running the BFS, if you know what I mean, right? Yeah. So, and I think it should be also pretty straightforward to implement such thing. So orbits tree, right, and it's gonna be orbits map. I wish these things were actually completely separate types so I don't confuse them accidentally. Yeah, I think I need to make them completely different types. So it's gonna be actually data. So orbits tree, OT map. So orbit tree is gonna be something like this. And after that, after you constructed that, we're gonna construct orbits tree out of this. And every time you look up, right? Every time you look up, you'll have to do OT map, and only then you will be able to look it up, right? And in here we have orbits map, which is also going to be a completely different thing. Yeah, OM map, so that gives us the map. And here from list we also wrap it into orbits map like this. But what will make it completely different is that it has reversed edges. It's gonna have the reversed edges. Deriving show. So it has the reversed edges. Cool. How can we reverse them? Essentially, yeah, we can do something like concat map, and we can do the following thing where we also reverse them. There we go. So this is basically the difference between them. And all of that compiles. So we can do orbits map from file, and it's going to be a sample txt. So yeah, so now you have this kind of thing. So you can go from B to com and from com to B. You see? And what's cool is that you cannot use solve DFS on this map. It's not gonna type check. You see, it expects orbit map, not orbits tree. So yeah, on the level of types, I actually not allowed to use orbits map in this solution, because if I try to use it in this solution, it's gonna basically loop itself. So this is how I can semantically like document what goes where and why. Which is not that important in competitive programming problems anyway, but it's kind of important in like real software development, right? So, yeah, makes sense. Yeah, and this is why I believe like statically typed languages that allow you to do these kind of things are very important for software development. Very important. They're really underrated. Alrighty, so cool. We need a second sample though. So this is the first sample. It's gonna be 01. Sample 02 txt, and let's actually grab this sample. Let's actually grab the sample. Oh, it's actually kind of funny. The first part was DFS, but the second part is going to be a BFS. It's literally just a single problem for you to implement first DFS and then implement BFS. That's actually pretty cool. Imagine talking with the bot. Alright. Did we really have Yusan? Oh yeah, so it's actually Yusan. Pog Yusan. Not a bot. Sure. Sure. You're not a bot. Okay, so the next thing we're gonna do solve BFS. We're gonna accept orbits map, actually, and return the solution. Orbits map. I guess we can just. So we know from where we have to start anyway. So whatever. So orbits map and we're gonna just return, we don't really have to return IO, it's gonna be int. So we need to figure out the starting point, right? So we need to figure out the starting point. We're gonna have solve BFS. Solve BFS, and we also need to maintain the BFS trace. We need to maintain the BFS trace somehow. Solve BFS prime. We don't need orbits here anymore. What we do need, in my opinion, is BFS trace. So we're gonna call it wave, right? And we're starting at not really U, but at this start. Your bot is not working. Are you debating me? If you're gonna debate me, you're gonna get timed out. Okay, timeout. Current is 10 minutes. I think 10 minutes timeout should be okay. Hello, Programador Binario. Welcome to the stream. My bot is working. Don't distract me intentionally, please. Okay. Alright, solve BFS. So this is the wave. We also need to keep track of what we already visited, so it's kind of important. And what's going to be the visited? That's a good question. It could be a set. It could be an empty set. Zozin Ikora Ball is bullying me. I don't know. You can ignore it, I suppose. Set as S. Right. So this is what we're gonna keep here. So basically the things we already visited. So wave visited undefined. So what's gonna be the start? Start, I think, is gonna be like this. Just m look up om orbits map orbits, and what we're looking up here is u, right? So I don't remember the order of these things. Look up. Yeah, first you take the key. Yeah, you first take the key, and only then you take the map itself. All right, and it will give you just start, and the end is gonna be the value for oh shit, it's actually it's really not gonna work that well. It's really not gonna work that well. Okay, so let me orbits map from file, right? Orbits map from file. So it's gonna be input txt, right? And what I'm gonna try to do, I'm gonna do om map, then m look up u, and you have only one here, and you have only one here. Perfect. This is exactly what I wanted. Cool. So I wasn't sure if it's gonna work out like this. Yep, it's pretty cool. So here's the start and the end. Here's the start and the end. The question is, what is going to be the wave? It's a good question. What's going to be the wave? Solve BFS prime. So the wave is going to be actually pairs, the name of the object, right? The name. We can actually have like semantic information here, name and the path, which is integer. So how many steps you had to make. So, and then this is going to be a set that contains things that we already visited, and it's going to return the solution, the final solution. So this is how it's going to work. If it's nothing, then does it crash at runtime? Yes, that means the input is not correct. So, and this is exactly what we want here, right? So it's a solution that works for very specific input, and yeah, the invariant here is that U always has like thing from which we can start, and san also. Yeah, you can bind like that, and it will essentially just crash at you know, at compile time, at runtime, right? So we have something like that, X and Y. But if this entire thing doesn't have the shape that you expected, wait, what? Oh, okay, so it was lazy. Holy shit, this is the laziness of Haskell. So yeah, essentially it will crash at runtime, so which is very useful because in these particular situations, like there's nothing much you can do, your data is incorrect, well, let's just crash, and this is exactly what you want here. Hello Raiders, hello Commander Elel, I hope I'm pronouncing them correctly, welcome. It's like Rust's let some, but there's no if. Yeah, so it's let's cucumber some. What is the estimate time to finish this Advent of Code minigame? Is it less commitment than marriage? You have interesting priorities. Okay, so let's continue. So the wave, we start at the start. So, and by the way, that means that here we have to put something like 0 here because we start at 0. And I also need to introduce like the name thing. Name is going to be simply a string, t text. So solve.dfs, you started a name, okay. Oh, you mean how much does it take to solve all of that? Holy shit, you could have just asked how much time does it usually take to solve Advent of Code? Well, so instead of problems you have days, right? Instead of problems you have days, and you have 25 problems for 25 days. So it's 25 days commitment. Is that if that's what you mean? I guess I'm not sure what you mean. You speak really strange language that I don't understand. All right. So we have that, and Yesu, kawaii desu. So we need to check a very interesting condition. If wave contains the end, if wave contains the end, we have to stop and return that, right? We have to return the end. So, all right, we can try to do something like this. So filter, filter FST, so first equal end on the wave, and then we can pattern match this entire thing, right? Case off, right? So, all right. If it's end and we found something, right? If we found this particular shape and this is the answer, we can return that answer right away. If it's something else, right? If it's something else, actually, if it's like empty, so because maybe we'll run into the situations where you have several answers, which is no bueno. So if it's empty, we need to start going a little bit deeper, right? We need to start going a little bit deeper. So what we need to do here is essentially filter out everything that we already visited, right? Let me actually check if this still compiles. It doesn't compile because origin orbits. There we go. This is what I meant. I meant orbits. There we go. Cool. So I want to filter everything that we already visited. Contains. How do you do that? Get, find, lookup. Oh, okay, it's lookup. Nice. Oh, it's lookup grader. Oh my god. Okay, find index. Okay. I want to check if it even contains an element. Is it element? Elements. How can I check? I have an element. Can I check if it contains? Okay, member. Holy shit. Fucking languages cannot get their shit together. I'm naming these things differently every fucking time. Alright. So, thank you so much. Thank you. Member. Okay, so this is that, and yeah, we can easily check if it's there. Oh, it's so inconvenient. Okay, filter an element, and we have to do it like that because the first is the name and then this thing. So name s member, right? S member, take that name, and we also need to accept the visited things, right? So we need to look at the things that are not, yeah, not member of the visited gang, right? So we take the wave and we filter out everything that is not visited. Okay, and this is what we're gonna work with here. This is what we're gonna work with. So we're gonna assign it not visited. Cool. In this particular situation, cool, not visited. Then we need to add them to visited at some point, but we can do that separately anyway. Let's do the next call. So it has to be solve BFS, and we need to update a wave and the visited. So how do I add more stuff into the set? Does set accept like a bunch of things that I can just dump into it? So this is a good question. Let's go to the Google. So does it have something like / insert, like insertion? You can insert one element, but what if I have a group of them? Well, I can just, you know, oh, it's even inverted, like, so inconvenient. You can do union, I suppose. You can do union. I think we can, like, first you have to transform it as a set, and then you have to do union. All right, let's do a union. So we take not visited, right? But we need to take their name, so we'll have to map it to SND. So then we do from list, right? This is what we get here. We get from list, and then we do S. Well, we can do something like this then. S union visited, right? So yeah, I guess I can do something like that. Yeah. So S union visited map SND visited from list, and then this becomes visited. Can I put undefined here and check if it compiles? Set of integers, it actually has to be FST. Zozin, it's FST. The compiler won't tell you that it's FST. Okay, let's continue. So the next one is gonna be the next wave. The next wave is very interesting. So we essentially need to do concat map. And what we get here is the name and the length. Let's call it path, right? Let's call it path. And essentially, we use that name to look up all of the children that we have to go through, right? So it's going to be something like m lookup om map orbits. From that, okay, it has to be like this name. So that gives us maybe list, right? But if it returns nothing, we want to treat it as just a regular list. So what I can do here is maybe to list and just concatenate this entire thing. And that way, if it's nothing, it will be just an empty list. But on top of that, I also need to map them all in the following way. So this is going to be a child, and it's going to be a child with path +1. So I need to increment their path. Does it make sense? So I take off the children, take all of the children, and there we go. And then I just, let it grow even further. And I guess that's the solution here. It doesn't compile because we don't have maybe to list. Import data maybe, and concat map. We don't have a concat map, or did I use something incorrectly? So instead of list, okay, so I think I didn't fully finish something. Ah, I have to apply not visited here. Okay, it's just not visited like that. There we go. And it compiles. Look at that. Look at that beautiful code. It's a BFS in Haskell. There's nothing to be scared about. BFS in Haskell. Will it work? I don't know. What are we supposed to output? We're supposed to output the shortest path. Right, and in this particular case it's gonna be 4. We keep maintaining the visited, and yeah, it even like compiles properly and shit. Okay, so where's the function? Orbits map from file. Cool. Orbits map from file. BF. Very funny. Very funny. Okay, so sample 02. And does it contains U? It does contain U and Santa. Pog U. Solve BFS. Right, so we apply it like that, and then we're starting from. We don't even need to start from U because it doesn't even accept any starts. So I think it's kind of redundant, and it is in fact 4. Look at that. It's 4. So sample works correctly. Isn't that amazing? I think it's good and amazing. So let's try to use that on the input. Not even 420, what the fuck? Why is this not 420? I'm disappointed. First try. So far, we first tried all of the problems. Not even 420, yeah, I know. Another first try. But since we are programming in Haskell, and Haskell is a language for nerds, not that many people saw yet another first try. Right, because boo-hoo, Haskell is unreadable. I'm gonna close the stream, yes. Yes, so we solved 3 days in 1 day, 4, 5, 6. So let's actually, you know, continue. So I want to kind of, yeah, what I want to hear is I want to clean up everything. So it's gonna be like this. Orbit tree from file, and it's gonna be input txt, input txt, and it's gonna be solve DFS starting from com, right? So what that gives us is this interesting thing. I wonder if I can continue mapping this entire stuff, for example. That gives me the result, right? That gives me the result. And I just need to write it, I suppose. Wait a second. So can I... So I probably have to also return true, but it actually depends. I don't remember what I have to do here. And then I want to do show.print. Will that work? It doesn't work. Interesting. Oh, you don't have to do that, so it has to be like a print. Com is not string. Oh, okay, so that means I need to overload strings. Okay, so what does it say? No instance is string for IO name. Ah, yeah, so it has to be returned. That's why I couldn't compile it properly. Yeah, so that means you can actually print it like that. That's cool. Is it correct? Wait a second. What was it correct? No, not sick. Oh, for fuck's sake. So what was the answer? Yeah, it is correct. So, and that means I can probably do something like part 1. It has to be D. Right, and if I do that, and of course, I need to import this entire thing. Text printf. Come on, main. Cool. Another thing I want to do here is solve BFS, right? But instead of trees, we're going to use map. And we don't need to do that thing anymore because we already know where it begins and stuff. Right, and this one is going to be part 2. And why didn't it work? I have no idea. It's really kind of dumb in my opinion. So because of the order of this shit, so you have to wrap it in parentheses because Haskell. No, it's not because of that. It's not because of that, because of do. Cool. I'm just, like, I'm speechless sometimes. Okay. Alright, so this is gonna be day 6. Right, day 6 solution. Day 6 solution, and then we're gonna have expected results. So what's gonna be the expected results? Console. Add day 6 solution. There we go. I'm actually doubting if I want to continue AOC 2019 in Haskell. Because it's not really that good of a content. Actually, kind of. Not sure. People don't like it. Anyway. Today was a pretty good stream, I suppose, in terms of productivity, at least in terms of productivity, like I, did something, solved a couple of problems and shit. But unfortunately, boys and girls, I'm streaming for 5 hours. Feel like I wasted a lot of time. It is time for me to go. I'll think if I want to continue this challenge. I think it's not worth it. Thanks everyone who's watching me now. I really appreciate it. Have a good one, and I see you tomorrow. Tomorrow we're supposed to be, yeah, we're gonna do a game development, right? We're gonna do a game development in C++, and after the game development, we're gonna continue doing virtual machine. We're gonna continue doing virtual machine in C. Check out the schedule for more information on different projects we're working on. We're working on different projects and stuff like that. Also check out our VODs channel where we upload all of our streams. Right, this stream is going to be there, but tomorrow, right, is going to be tomorrow because we upload them on the next day. And also check out our Discord server for offline discussion with the community. So yeah, so far I really like to AOC 2019 is just like, I guess Haskell ruins it for everyone, right? Because like not a lot of people can read Haskell, so people just don't like it. It's interesting. Anyways, thanks everyone for watching. Love you.